Okay, so the recording has started. Anyone any issue from yesterday's class? So can someone tell me what all we discussed yesterday? And those who joined new, like who didn't join yesterday's class, have you guys revised? Do you guys check the video? Did you get time? I mean, we just discussed very basic things. We haven't like stepped a lot because it was just the first day. So any doubt from yesterday? Like if anything is pending, let me know before I begin. How to use, as in, are you not able to set up PG admin? So basic, I will tell that because we'll start coding in detail from next class. So maybe this week I'll create a video on that, or I'll share I'll find some good video and I will not write command. So basically, when you open this, okay, from here you have to go to servers and you have to set it up. Like you have to put your password. Once you enter there, you see this database button at the top left, right? You just need to click that and it will open the query pad for you. So you just need to click this. For example, let me close this first of all. Let me show you. So if I go, I just search PG admin. Okay, I'll so this will open. And if you check, first of all, click servers here. In servers, it will open whatever servers are presently there for you. If you go here, query tool, click on this, and it will open the coder pad for you. From here, you can reset your layout, like vertical, horizontal, stacked. You can choose whatever you want. So, right. So just try this; it will work for you. Okay. So let's begin. No one has any doubt from yesterday's class. So let this I've shared this drive basically, which I shared every day's material content, whatever I'm going to teach, Excel file or whatever is going to be present there. So just go from here and today's content is present. You can download from there. So I'm just sharing a link in the chat box. You can simply download from there. So at least download this particular file, web series, and Excel you can leave. You can see that because the first two you can see after class. Just download this web series PDF. Let and let
Bro, bro, can you send this one through email?
I shared on you guys have access to this drive. I've shared the link with you. Check access to this particular drive. You can open and save it in your drive. Then you will keep getting updates. Let me know if you guys are able to download the file. I will teach how to create a database in today's class. Don't worry.
Hello. So,
Yeah. Can everyone please confirm if they are able to download the PDF?
like, yeah, we are able to access the PDF. We can download it. Yeah, I have downloaded it.
Sorry.
Yeah, we are able to access the PDF. We have downloaded the PDF of the web series and the other two things.
Sure. So everyone has downloaded. Anyone who is not able to download, guys, please mute yourself when you're not speaking. Please mute yourself. Otherwise, I will have to mute. Shekhar, please mute yourself. Yeah.
Sorry,
Guys,
bro.
please, when you're not speaking, please mute yourself because there are others as well on the call, please. Just a humble request. Okay, so everyone is having this file. Okay, so do one thing. So what you have to do basically, go to that. If you open this PDF, you just copy this whole code, okay, and paste it in your whatever SQL server you are using. For example, if you're using Postgres, just go paste here and just for example, you can call it and just run and see if you're able to access that particular table. If you're able to run and create the table as well, just first of all do that.
Bro, any database we need to create?
That's what I just told.
Which one, bro?
I shared a PDF with you. Open the PDF, copy the code, paste it in your whatever SQL you're using, and run the code and see if you're able to access, create the table or not.
Okay.
So, like, I am able to get it, some table like this. Check if you guys are able to create this table or not. Let me know, please. How to create a database, I will tell in today's class, but right now, this is for something else. First, create this database. I shared a PDF file. Go to the PDF file, copy the code. This is the PDF file. Copy the whole code which is present in the PDF file. This whole code, copy it. And go to your SQL server wherever you are coding, paste it and run the code. And then run this query, select star from whatever your table name is, and check that are you able to get this table or not.
Yes, perfectly fine. We are able to run the code.
Please everyone confirm me once you are able to do. Just write a yes if you are able to do, please.
Yeah, done.
Okay. Can everyone confirm it? There are like I'm waiting. There are only 6-7 people replied. Anyone who is not able to, who is facing trouble, let me know, please. Okay. Okay, perfect. So this is a database. Basically, this is a table. If you see, it contains some 15 rows. It has some web series, their genre, language, release year, platform, rating. Some information is given about them. Okay. So what you have to do is, I'm displaying questions on screen. You have to solve them. And so first, we'll solve them one by one. Okay. And I'm giving at max 5 minutes for each, not five, yeah, at max 5 minutes for each question. Okay. You have to write down and confirm if you're able to do generate or not, and copy your code and paste in the chat box. Okay. So first of all, we will do a revision of yesterday. I'm not going to tell you because we discussed, this is all that we discussed yesterday. Okay. This is nothing new. So this is the table. You have this. So first solve the question number 1. Okay. You have the data. The question is here. Is my screen visible or shall I zoom in?
Okay, sir.
Okay. If I zoom in, the question will go away. Try to see this.
Yeah,
Please,
sir. Don't zoom in the question because I can't see the entire table. Yeah, that's the thing.
the table you can see from your you have the table, right? I just created this, but this is the table that I created. So the first you have to solve the question number 1. So already timer has started. So solve that and tell me. Write down your query. Write down whether you're able to do it or not. And if you're not able to do it, be honest. Tell me. Okay. Which previous command you're not able to see? You're able to run the table, right? Just write down select star from your table name. That's it. Run the code that I gave. After that, run this query. Select star from, change this. This should be your table name, the table name that you created. It should be that.
So can you please go back to the question, please? I'm so sorry.
Yeah, please.
Yeah.
This is the question. Ashish, are you able to get the table? Just write down select star from the table name that you created. That will give you the table. Now, right now, solve the question that is there. I've got only 3 responses now. Only 1 minute is left. Okay, so first question is clear to everyone. Anyone who is not able to solve the first question? Yeah, I'll copy the link. Anyone who is not able to solve the first question, tell me. Guys, you have to be honest with me. If you don't tell me right now, then please don't tell me after class that I didn't understand that question. This is the time you should ask question if you're not able to ask, if you're not able to solve. That is the objective of live class. Otherwise, we could have done a recorded course as well, right? So if you're not able to solve, be upfront, tell me here only so that I spend time. Now let's solve the question number 2. Those who are able to solve question number 1, solve question number 2 now. There are 25 people on the call, 24 apart from me. So, Priya, are you not able to create the table? Go to the PDF that I gave. I gave this particular PDF, right? Sorry. Copy the whole table. Just copy everything. Control C. Go to your SQL, whatever you're using. Paste there. And just run the command. You will be able to create the table. Let me know if you are able to do this now.
Sir, please question.
Give me a second. Give me a second. Uh, yeah. So Priya, let me know if you're able to do this. Copy the code in the PDF to your SQL server and run it, and then tell me if you're able to get the table. What error is coming? What is the error? Can you tell me? This is a simple, straightforward code. It should not give error. What did you write in the select statement? Priya and Ashish, tell me, are you able to create the table or not? So that is a problem. You just copied what I wrote. What is the table name I created? The table name is Indian web series. I just changed the name to web series. So the table name you should use this. You can change the name. You can change it as per your need. So use this name. Then only you will be able to get. Priya, are you able to get the table? I cannot hear you. Can anyone hear her? I cannot hear you.
Yeah, Sadhvik, I can hear you. Yep.
No, not me. She's saying that she's speaking. Syntax error at line 22. What is the error at line 22? Do one thing, copy one by one. First, copy the create table command, then copy the insert command. You should get it.
Sir, please can I see the third question if possible?
So people, yeah, solve all the 5 questions. Like you guys can see the questions, right? So these 5 questions are there. Solve them. You have like 15 minutes of time overall.
Bro, can you paste these questions, please?
Go to the drive that I shared. In the drive, download this Excel data modeling.
Excel sheet, okay.
Yeah, in Excel sheet, the first sheet has the questions. Try to copy the first select statement. After that, the sorry, create statement. Then copy the insert commands. Then you will be able to get. So you have 15 minutes to solve these 5 questions. Okay, great. Now please solve the questions. So right now it's 8:30 p.m. in India, right? So you have time till uh 45, 8:45. Okay, 15 minutes I'm given. 15 minutes are more than enough, to be honest. When you're writing on a question, just write down question number as well when you're putting your answer. Like question number one, answer this. Question number two, answer.
So sorry. I just posted the third one without
No problem.
mentioning the question. I'm so
From
sorry.
now onwards, yeah.
Satvik, can you please share that Excel file with again
I
Google Drive?
shared in I shared in the link group.
Actually, I did not find it that.
Check, and I just pasted in the chat box.
Okay, thank you.
You have 14 minutes remaining. Please finish by then. All the 5 questions.
Sir, for the question 4 answer, I've just written Q4. Is it like fine, right? For the question 4?
Yeah, yeah. Uh, no SQL Server has limit, I think, as far as I know. Oh, okay. Sorry, I just checked. SQL Server does not support limit. Oh, this is new to me as well.
Sir, I have submitted the fifth answer, but I don't know.
No problem, Supriya. You can just write down the code. Uh, if possible, you can shift to MySQL or Postgres. Uh, like I'll tell you, there are ways to do in SQL Server as well. Does it support? Does SQL Server support? I haven't used it. That's why I'm asking. Anyone who is using SQL Server, can you see limit? Okay. I just googled it. In Google, it just said it does not support. So, it supports top. Yeah. No problem, Supriya. Just write down the code. Once we study those commands, I will cover that. Don't worry. But try if you can get MySQL or Postgres. But just write down your query based on whatever we discussed. Just write down your query. Rest we will see. So we have 7 minutes remaining. Okay. After that, you should stop coding. Aniket, your code has one issue. Check it. The offset is not correct.
Oh, okay.
Priyanka, your fifth question is incorrect. 4 minutes remaining, guys, to solve all the 5 questions. Ramakrishna, your fifth question is incorrect. There is some issue in that. I mean, it's mostly correct, but towards the end there is some issue.
So
Okay.
mine's limit is incorrect, right? I guess it might be offset. I'm like, I don't know.
Limit should be 3, not 6.
Yeah, limit. No, I'm talking about mine. Like, the fifth question that I submitted.
The fifth question that you submitted, you had some error. Yeah, I remember. Wait a second, let me check. You mentioned offset as 4. It should not be 4.
Yeah. That's the only mistake, right?
Yeah, that's the only mistake. Fifth question is incorrect by Ankan Banerjee as well. Tell me, shall limit be 3 or 6? That's the question. This is the trick that you need to think that what should be the uh, value in limit and offset. And Shri Vidya, your query is although it's correct, but there is some issue. The
Yeah, I'm also getting a little error at the order by
because
clause.
limit should come to the end, not before order by. Put the
Okay.
limit part to the end.
Okay, thanks.
Satvik, can I know what is my error? Is this
Who
with
is this? Who is this?
Ramakrishna?
Uh, where are you? Okay.
Is the error with
You said
order?
limit. You said limit 6. Limit should not be 6.
Okay.
Sir, I've reframed the answer for the fifth one by having the limit 3 and offset 3.
Yeah. So okay, it's fine. So time is up. Please stop coding now. Okay. Now, based on whatever you coded, whatever, just tell in comment out of 5 how many you were able to solve correctly. And please stop coding now. It's over. Time is over. So out of 5, how many you were able to solve? Because you're using or, there is and statement in fifth. 4, 4, 4. Okay. 3. It's fine, guys. Don't worry. I mean, if you're not able to solve, it's totally fine. This is just to revise whatever we did yesterday. Okay. Uh, okay. 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 So let's do one thing. I'll just quickly walk through each of the question and then we will start today's session. Okay. So the first question.
Guru, Bro, a small request, like these questions, can you provide after the classes so that we can practice?
I have already shared the Excel.
Uh, Not like this today. Today you have shared the questions, right? Right now.
Yes.
Like this questions, can you share
I
any
will
other
share. I
questions?
told you I have not started giving assignments yet.
Yeah,
Okay.
but suddenly you gave this many questions. I just done
What,
only
what
one.
do you expect? I will come and give someone. This is a course, right? This is a coding course. You know that, right? So
Yes, bro.
I'll give these questions only. So I'll give assignments as well. Don't worry. Okay. So I just wanted to see how much are you prepared. Okay. So now let's just discuss. I will not spend much time because we already did all that, but still let's go through. So first question says that find all the web series released after 2018 with a rating above this and this and this. Sort the result by in the descending order. So let's go to the coder pad. So first let me do select star from web series just to get my table. Okay. So if I go to the question once again, the question says that what do I need? Web series that released after 2000. So remember the step that we created yesterday, how to solve the question, SQL questions. Again, till now, like I will give the main architecture in future classes. We discussed select, we discussed from, we discussed where. What else we discussed yesterday?
Order.
Order
Order
by,
based on limit.
limit,
Yes,
and offset. We discussed these things yesterday, right? So
yes.
first of all, you have to, before solving the question, just write down these things. Okay. Again, this is just a temporary approach. We will come to the main approach later. Just write down all this. Okay. Now let's read the question and let's try to fill in all this. Okay. First says all the web series. So they want all the web series. So either you can do select star, you can just select the title. So let's say I'm just doing title because it's not mentioned that what you need. I'm just using title. You can do select star as well. So that's not a problem. Which released after 2018 with a rating above this and budget. So these are three conditions, right? So in the where I have three conditions. First, release year greater than this. Okay. So here will be table name web series. Okay. Where released underscore year greater than 2018, right? Released release underscore year is greater than this. Okay. And rating above 8.5. And so will this be or and tell me, or slash and rating greater than
And
4.5?
and
Why not or?
uh,
It should satisfy both the conditions. So we
We have
should
to
take.
find all the web series which released after 2018 which had a
Because
rating it, so right.
because the question is clear that you have to use both like and.
So it means so it didn't say that which released after 2018 or which had rating greater than 8.5. Okay. So and rating greater than 8.5, rating greater than 8.5. What else? Budget above 20 crores. So budget greater than 20. Okay. And budget greater than 20. So these were the where conditions which were present. Now let's see. Have they asked any order by? Let's read the question. Sort the results. Yes. By rating in descending order. So rating is where? Rating is here. I have to use rating in descending order. By rating DESC. Okay. And have they asked anything limit and all that? No, they have not asked any limit. That's it. So what you will do, you will simply run this particular code. Okay. This is something I got in the first question. Okay. Now let's similarly just follow this approach only for the second question. So for the second question, I will need to change the where clause. Okay. Well, and order by from will remain same. Put limit and offset as well. Okay, now let's read the question number 2. Question number 2 says retrieve titles, platforms, and audience scores. So I need three values: titles, title, platform, and audience underscore score. Where is audience score? This one. So first let me write down that. So it is audience. Sorry, what did they ask? Title. Okay. Title,
Platforms.
platform, right?
Yes.
And audience underscore score. This is what they asked, right? Platform or platforms? It's platform. Okay. Now with these three variables they asked. Now is there any filtering condition? Yes, with more than one season. So where I have to filter this, where episodes per season, with more than one season, sorry, where season is greater than one. Okay, where seasons is greater than one. Okay, this is it. What else I need? Sort the results by audience score in descending order. So I have to sort the result by audience score in descending order. Okay, that's it you need to do. So I'll get something. Okay, so this is my question number 2. Now again I'll move to question number 3. Remember what I'm doing? I'm just writing on everything that I know, and I'm just doing fill in the blanks. Okay, by reading the question. That's all I'm doing right now, and that's all I have taught you till. Okay, so list the titles, lead actors, and critic scores. So what do I need? Title. Where is lead actor? Lead actor and critic score. So title, lead underscore actor, comma, critic underscore score. Okay. Of the top 5 web series with the highest critic scores. So I want top 5 based on what?
Based on the critic scores.
Based on critic score. Is there any filtering condition here?
No.
No.
Right. So there is no filtering condition. So what I will do, I will remove the where clause. Okay. I don't need it. Order by critic, critic underscore score, right? Is it ascending or descending?
Descending.
Descending.
It top 5. So I'll use descending. Okay. And what else they have asked? They want 5. So I will use a limit of 5. That's it. So that's the question number 3. Okay. Now let's move to question number 4. So from this, where, okay, they were, and find the titles of all web series. I want titles. So first I will write down title here. So let's go one by one. Title from web series. Okay. From all the web series, let's read the question once again. With release year between 18 and 20. Okay. So with release year between 2018, where is release year? Okay.
1, 2, 3, 4. Fifth column.
5th column. So where release year, where release underscore year, between. So tell me, will endpoints be are included or not?
Oh yes, so we can add like between 2018 and
No, tell me, are endpoints included or not? What is the question asking?
Included.
Yes, and function will be included.
included.
But what is the question asking? It is, yeah. So basically anything that starts from 2018 1st January and which ends on December 31, 2020. Correct? That's what they are asking. Right?
Yes.
So We want where year greater than 2018 and less than. So we can use two methods where release year greater than equal to for example where is the table where release underscore year greater than equal to 2018. Okay, what else I can do? And or 2020.
20.
Okay, one is this method, or I can use where release year between 2018 and 2020, right? Between 2018 and 2020. You can use either way. Now, let's come. So first filter was between this year. Second was more than 8 episodes per season and a critique score high. So I have two more filters. More than 8 episodes per season. So I'll put down that and episodes underscore per underscore season greater than 8, and another filter critique score greater than 8.5. Where is critique score?
Last
Second
but one.
critique underscore score. So critique underscore score greater than how much?
8.5.
8.5. Okay. Is there any order by required?
Sort the
for the
result
result to release year in
ascending.
order. So order by release
By
underscore year. Correct. There is no
Yes.
limit. I will not use that. Okay. Now let's run this. I got the result. Okay. Now
So
let's
Sadhvik, do we have any limitation of using AND option here?
no. You can use as many and as you want. As
Okay.
many you can include 100 variables, 200 variables, 500
And
variables.
and if you can please explain like in what scenario OR will be used?
Or when, so I'm coming to that question. The fifth question contains or. See the fifth question. Okay.
Okay.
So select title where this order by this limit. So let's come to the last question. Questions has multiple conditions. Okay. It says that find the titles, platform, and director. First of all, I need title, platform, and director. So title, platform, and director. I will write down that. So select title, platform, and director from web series. After that, what is given? So see, one by one they have given conditions. Okay, that meet the following conditions. So sorry. So it means you have to satisfy condition number 1 as well, condition number 2 as well, condition number 3 as well. So what does it mean? That in the where condition 1 and condition 2 and condition 3 and condition 4, that so on it will go. Okay, so they have given us total 4 or 5 conditions. So for every condition I need to put an and inside each condition I have to read that condition separately. So the condition 1 is have a budget less than 40 crores, or someone was asking or, right? So they have mentioned budget should be less than 40 or rating greater than 8.3. So budget, so condition 1 will go under bracket, okay, where budget is less than 40 and or, sorry, they've given or in the question, right? So budget less than 40 or a rating greater than 8.3. So where is rating? This, or rating greater than 8.3. So this is your condition 1. Okay, inside this there is or. Now, when you go for the condition 2, there needs to be an and between condition 1 and condition 2. Remember, okay, lot of people, they used or here. No, they use multiple ors. No, there will be combination of or and. So you need to know how to use and how to use or. First of all, split all the condition that is given, and between each of the condition there will be an and. Okay, and then read each condition separately, whether it is asking and or it is asking or. So now let's read the condition number 2. Condition 2 says released in 2019 or later. It means release underscore year greater than equal to 2019. So this is my condition number 2. So I'll put it in bracket. Release underscore year greater than equal to 2019. Okay, this is my condition number 2. Now let's read the condition number 3. Belongs to the genre drama and or action. Remember, drama or action. Okay, so where is genre? Genre is this. So how to write this code? Condition 3 and genre in action
Drama.
and drama, right? This is your condition number 3. Now let's read the condition number 4. Exclude that. So these are all the filters. Exclude. So we are done with this part where so there were 3 conditions. Okay, so I have written down all the 3 conditions. 1, C1, C2, C3. There is and between each condition. Okay, now let's see about order by and limit. They say exclude the top 3 results with the highest rating. Okay, so sort the remaining result by this and by budget in ascending order. So first of all, what do I need to do? I need to exclude the top 3 results with the highest ratings. Okay, and so which happens? Sorting comes first, right? So order by should come first. Okay,
Yes.
but how will you exclude top 3 results with highest rating then?
So basically, we are going to limit it by 3 because we just want the top, like we just want 3 records, right?
No, limit is fine. First, understand what they're asking. They're asking exclude top 3 with the highest rating. And then sort it. Tell me this, if you sort the data first, okay, remember generally in SQL we sort the data first, right? Sort the remaining results by platform and so where is so order by platform. So let's say I do this order by platform ascending, or I can just simply leave it, and budget in ascending order. So budget also ascending order. So this budget in ascending order. Once you do this, you got something. But how will you put this condition? Exclude the top 3 results with the highest ratings. How are you doing this?
Need to mention rating.
This is where no one focused on.
So basically, like after ordering it, we can use offset, right? Like
if after ordering let's say after ordering, suppose you use limit. Okay, so let's say I do ratings. Let's say get the ratings here. Let me get the ratings as well.
Yes.
Sorry, what's the variable name?
Rating.
don't use the S, I guess.
Yes.
It's just
Remove
rating.
the
Rating. Okay. Now tell me, question says I need to exclude the top 3 results with the highest rating. What does it mean? I need to get rid of top three
High.
highest categories. Correct? Where are you getting this data? Is not sorted based on rating.
You need to rating also need to be given under order. Order by descent, DESC, I think.
Yes. So what you will do, first of all, your first wait a second. Your first sorting should be done on rating,
Okay.
descending.
Hmm.
Okay. This is the trick that everyone missed. You just wrote all that. Now, when you do, for example, now if you see your data is sorted by rating, correct?
Hmm. Yes.
Now limit and offset will make sense. Now after that, what do I need? I need 4 to 6. So remember, limit, say when you apply limit, that limit X, it means how many rows you want. So a lot of people use limit 6. No, if you say limit 6 means you want 6 rows. No, but the question says I want 3 rows. So limit should be 3 only. Okay. But I want from row number 4. So I need to exclude 1, 2, 3. Right? So how will I exclude? By saying offset 3. Offset, like someone wrote offset 4. Offset 4 means you are excluding 4 rows. No, I want to exclude 3 rows. Okay. So I will write down offset 3. This should be the correct answer. Is it clear why this is the something, this was the catch part which everyone missed? Clear? Anyone, any doubt? Please tell me before I move ahead.
No, bro.
So, Sadhak, can you please tell me offset being used whenever we want to exclude the rows from the results?
See, generally what happens, let's say if you just write down limit 3 here, okay? Or let's say forget limit. Let's say I tell you I want top 3 results. I want top 3 rows. So what will you do? You'll put a limit 3, you'll get these 3 rows, right? But let's say I tell you no, I want 3 rows, but I want row like row number 4, 5, 6. Let's say I want this, or I want these 3. So like the 3 is not starting from 1. Here the top 3 was starting from the first row. But what if those 3 are not starting from the first row? They're starting from somewhere else, like this, or like this,
Okay.
or like this. So what you do, you use offset. So for example, let us say you want these 3 rows. Okay. So you need to skip how many rows?
2
from the top. So you will write down limit 3. It means I want 3 rows only. Okay. And offset by 2. It means I will skip these 2 rows. That
So it means like offset by default pick the first rows, right?
by if you don't write down offset, it will take from the top 3.
Yeah, correct. Okay,
But
got it.
if you want to skip, 2 rows. So you will say offset 2. It means start from the 3rd row.
Okay. So that means like by default offset will start from the beginning, right?
Beginning, yes.
Okay. Okay. Thanks.
Sir, in the first way condition, is it necessary to keep the first condition like budget is greater than 40 or rating in the brackets? If we not like keep the bracket, it's still fine,
It's
right?
not necessary. I just wrote to clarify.
Yeah.
Because a lot of people are confused when to use and when to use or, right? So because there are 3 different conditions, I need to satisfy each of the condition. Okay. C1, C2, C3. It means there should be an and between each of the condition. And inside each condition, there can be or, there can be and. That's why I put a bracket. Bracket is not mandatory.
Yeah.
Anyone, any doubt in these 5 questions?
Uh,
This is just a beginning. Yeah, please.
One question is like we have the keyword for the top to get the top category. You are using limit, right? In the same way, how can you get the bottom ones if you want to get the in the bottom titles in the list? What keyword can we use? We want to have the
If you want
bottom.
bottom, tell me
Yeah.
this. There's no keyword for bottom, but instead of doing descending, you will do ascending here, right?
Yes. Okay.
And
Yeah.
so reverse and get the top three,
Okay. Yeah. Thanks. Yeah.
right? So basically, right now it is sorted in descending. If I want bottom three, what will I do? I will do an do instead of I'll do a sort by ascending in order. Ascending, then I will do top three. Then I'll use same limit only. Do you get this? So suppose I use ascending. I got these. Remember, these top three here were the bottom three in the previous condition. Now I will use limit three. Okay. So there's no keyword to get the bottom three.
Okay. Thank you.
But if we don't use the brackets for the first condition, condition, how does the condition change?
No, sir. The output changes. You see, if you don't use the brackets after where for the first condition, then the output changes.
Let me check it. You're saying if I remove all these brackets.
Yes.
Okay, where budget is less than 40 or rating. Oh yes, sorry, I forgot to tell you. Now think this way. What happens that whatever you are writing, so basically this is one condition, right? If I am using this is your
That's the reason I told you, because I got the different result when not keeping in bracket. So I was like, is it necessary to keep that in bracket?
wait a second. No, it's necessary. The reason, and let me tell you the reason. Okay, this is my condition. Okay, so what is happening, right? So when you don't put, okay, for example, let me tell you what it is doing. If you don't put any bracket, okay, it will check either, let's say when it is comparing or, okay, so when comparing or, it will check either this correct or this correct. Okay, that's why it changes. Then when you're using or, yeah, so that's why you need to put this part in bracket. When you're using or, you need to put it in bracket. For and it's fine. I think for or you need to put it in bracket. Yeah. Okay, so what is the condition when you say or? Remember, or and they both are priority orders. Okay, so when you use or, it will check either the left part, okay, or the right part. So it will compare this with this whole. Okay, this is one condition for or. Remember, or and are two different keywords. Or has a precedence over and. Okay, so when you use or, it will compare the left part or the right part. So if right condition is getting set, so what is the right condition? Rating greater than 8.3 and release year this and genre. This is your one condition. So this becomes, so your condition actually changes. Getting my point? So you have to put the or part in bracket, and for and part you are good. And part you don't need to put in bracket. Is it clear? Anyone, any doubt?
Yeah, I have a doubt.
Yeah.
If we want to exclude, I want to exclude top highest ratings and top two lowest rating. How could we exclude that 4 rows?
So, see, for that window functions will come in. I haven't reached there. For that, we need little bit advanced knowledge.
Okay. Thank you.
I have one question here. As you said, like we are using or and, right? So we have a
Yeah.
third condition, right? Genre is equal to like we have drama and action, right?
Yeah.
According to question. So why we have used like genre in and then bracket like action and drama here? So can you explain
So
here?
you want to check genre. Genre can be one of, right?
Yeah.
So genre, the condition says that genre could be either action or drama, right?
Yes.
So there are two ways to write it. Either you mention and, let's say, genre equal to action, okay, or genre equal to drama, okay. But here, because you're using or, you need to put a bracket. So you can either write this way, or you can write the other way as well, which I told yesterday. And genre in. And when you say in, you give a list that, okay, it could be an action, it could be a drama, or you can give 500 more conditions. It will check if genre is having any of these values. It will give the true result.
Sure.
Is it clear?
Yes, got it.
Guys, any doubt in these 5 questions? Anyone? See, during the course, you will be surprised with such tests. Like this was just a very basic test. I can give random questions anytime for you guys to solve. Okay, so be prepared. That's what my message is. I can ask, for example, I might say today's a surprise test of 1 hour, right? Like, okay, so you should be ready always. So, like, revise the lecture that week only. Don't leave things pending. That's what my message is. So anyone, any question before I move ahead to the topic of today's class? So let's do one thing. Let's take a 10-minute break, okay, and then we discuss the data modeling in the second half of the session. Okay, so right now it's 8:48. Sorry, my 8:48. What's the time in India?
9:18.
9:18. So let's reconnect at 9:30. Okay. Till then, I'm here to solve the doubts. In the remaining half part of the session, we will discuss the data modeling. Okay. Yeah. So by rest, if others have doubt, please you can ask me. I'm here only. Which question?
Yeah, actually, this question I have seen that in that question only fourth and fifth row. I'm I'm not available to.
So I didn't get your question. What is your question?
Can you please share that screen question table data?
Okay.
Yeah, fifth question is sort the remaining results first by the platform or alphabet order.
Yeah.
Display only the fourth and sixth row. Fourth to sixth row. Sorry, that's my mistake.
Yes.
Yeah. Sorry.
Is it clear?
Yeah.
So yeah, let me know if you guys have any question in the topics that we discussed today. Like, we didn't discuss anything new. This is all that we discussed yesterday, but just a quick revision so that you guys don't forget. And just to tell you, this is the most lightest week in this course. From next week onwards, you will get assignments. You'll get a lot of things I have planned. Please mute yourself. Shekhar, please mute yourself.
So recently in the job market, we are seeing that most of the data scientists and data engineers are taking the position of data analysts just because they're not getting into their particular designation, and we are seeing a lot of crowd going towards a data analyst post only. So what makes a data analyst post such a
Wait a second. Wait a second. Guys, please, guys, mute yourself. Otherwise, I will have to remove from the call. Please, it's a humble request. If you're not speaking, please put yourself on mute. Yeah, please repeat again. The output of the fifth question, right? So the output of the fifth question is limit 3, offset 3. So this is the output of the fifth question. The table data is present in the Excel. I remember I shared the drive link. If you go to the drive, you have this Excel. In this Excel, everything is present that I just showed. So just use this link. That I pasted here. This is the Excel. In the Excel, the first sheet is questions. You will have the question and you will have the table as well. And the table data is also there in the drive, the link that I shared. Is it clear? Yeah, please. Someone was asking a question.
Hello, I shared one query. Can you please validate once? I tried in my Postgres SQL. It is not giving any result. Where I made mistake.
Select title platform title rating from Indian web series where this and genre in this. What is your second? Okay, this is genre and release year greater than equal to 2019. Order by rating descending. So my table name is web series. Okay, so something wrong we have done here. Let me just cross check. The question says budget less than 40 or a rating greater than 8.3. Okay, so this part is correct. Order by rating should be descending, right?
No, I think.
Wait a second. This is the first part which is correct. So let's do one thing. Let's just remove this part.
Table name was incorrect. Indian web series.
No. That I changed. Okay. See, till this part, if I remove this part, things are working. Correct?
Yes.
So the error is somewhere here. Now let's read there. And genre in drama. This is the error. You are using small d. In the table, it is capital D. See, drama action. This is string. So you need to exactly name exactly which is there.
Okay.
So this has to be drama and action.
Okay.
This is exact string. So this is not a variable name. You can in variable name your caps like upper space or lower space does not matter. But in the value it matters. Now you got the answer.
Okay. Thank you.
Sure. Anyone, any other question before? Like we have 5 minutes remaining. No question, anyone? Good.
Hello.
Yeah, please.
So, Priya this side. So, I just want to know, once we write the query, then how to save the query, or is there any shortcut where we can run multiple queries?
See, in PostgreSQL, it is not different servers they provide. For example, if you use a Snowflake, right? Suppose you have lot of codes written, you can simply select that code and run that. In Postgres, I haven't seen that option. It might be there, but I'm not sure. So you have to like actually save, like you can save the code from here, save file, so that you can access it next time. Is it fine?
Yes. Thank you.
No problem. So basically, this website which I told, right, you will get, right now you don't have access. So when you'll go to practice questions, there will be a lot of filters, like whether you solved a question or didn't solve, easy, medium, difficult. There will be subtopics as well, and there will be fields for companies as well. Like there are, we have around 400 to 450 questions which are from companies, like which have been asked in companies. So you can filter the question based on companies as well. Right now it's not there, but it will be added very soon, in a couple of weeks only. So you go to solve, and then you have the question, you have the tables. So this is the table, this is the expected answer. So you need to see that, okay, I need to get this as my output. Okay, and then you can put your comment here. Solution text will be available, video solution will be available here. It's not there right now, but you will get it. And then you can submit answers here, and there will be, in future there will be an AI chatbot through which you can chat and get the answer. So these things are there. And similarly, like we will conduct lot of live quizzes in coming days, not only in this course, in general, in the data science platform only. So please participate in all that. Like if you go to live quiz, like we conducted a Python live test this weekend. So there is that window, for example, 24 hours, 48 hours, you have to solve the questions in that time. You have to attempt the question, the test in that particular window. Once the window gets over, you get a result based on ranking, based on your scores, like that. Okay, so keep participating in those events. These events are free right now, so make as much use as possible. Okay.
For SQL also will be there, bro.
Yeah, for SQL. The next weekend there's a test on SQL. So this week it was for Python, next week it's on SQL. Now that SQL is for everyone, so not for this course. So the questions can be a little bit difficult. So if you're not able to solve, that is fine. But there will be SQL test next weekend.
So why don't you decide to have a course on Power BI too? Like it will be great to have a Power BI entire course, like a paid course I'm talking about. It will be.
Yeah, I mean courses. So I can have lot of. I need to have time. I need to have.
Oh yeah, yes.
That's the problem. I have my regular job as well, right? So. Plus, eventually, what interests me, I'll tell you, be very honest, coding is something that interests me a lot. That's why I mainly conduct for these AIML, those particular things. But it's a print. Plus, Power BI, there are a lot of things. I have built Power BI dashboards, but I still feel I'm not the right person, not that expert in Power BI. So that's why I do not launch courses on Power BI. But yeah, there will be someone on our platform soon. He or she will teach.
Bro, which you have launched till now? SQL and Python, huh?
I launched Python. So Python, I have launched. I launched a free course on Python. Then I launched a paid course as well. So they are almost about to be over. And this is a sequel course. After this, I'll take some break, and I'll decide which course I want to launch next. Yeah. But data science, as I mentioned, it's not about just courses. We are building this practice website, as I mentioned, where right now it will not only be coding platform. There will be data analytics case studies. There will be a website, project.datascienceai.com, where you can go and do projects live on our website. Okay, so those things we are building. So courses, yeah, I mean, I just keep on doing parallelly, but they are not the main thing of data science. So
Sir, execute the main course, how to get a job. That course will be beneficial for everyone.
there's no single formula for that. That's the problem. Otherwise, I would have. Everyone gives different advice. Everyone, something works for you, something can work for me. That's how the market is. Plus, I am in US, right? Job market is India is totally different, right? And so it get difficult to generalize. But
We
few
we
steps
can
remain.
come US also, bro.
Come, please. I have not stopped you here.
But I'll suggest you one thing. Please don't come for education. If you have a lot of money, then it's fine. If you're coming like Satvik sir on H1B visa, then it's amazing. It's a lifetime achievement. But don't come here for study. I mean, like, yeah, it's my personal suggestion.
But max people come for study only. Okay, so we have the time is up. So I think everyone is back. So let's start with the discussion of today's discussion. So today now we are going to discuss about data modeling. Yesterday we discussed about data pipelines. Okay, now it's about data modeling. The one of the very important concept. Conceptually, you need to know this because in interviews you are tested on this, and whenever you will, like, lot of people, as I mentioned, will not be just working as a data analyst, especially the people who are going to work in data engineering. This part is very important for them. Okay, even for people who are going to work, I will say, in AIML as well, not that much, but still they should know this because these terms are used very frequently there. So you should know. And for data analyst as well, it's like knowledge is good. So as simple as that, right? So try to focus on this is a very important part because coding and all that is fine. Coding is one part. This is the theoretical part of SQL, which you need to know, which can be tested. Okay, so first of all, I'm asking question from everyone. Tell me this, either through chat box or you can comment, you can unmute. Which of the statements is true? A table contains a set of databases, or a database contains a set of data tables?
A database contains a set of tables.
Yeah, second one.
Second one.
Second one.
Anyone who thinks first statement is true? Okay, so good enough. Yeah. So basically, second statement is true. A database is something that contains a set of tables. Okay. So yesterday we discussed about there are different type of databases. Like we discussed about SQL, NoSQL, and lot of things. So now this course is about SQL databases only. Okay. So in any SQL database, for example, just like we have the Postgres here, I showed, right? There could be multiple tables present in it. But let's understand what is a database, because database was not always there. Okay, it like data was always there, but database was not always there. Okay, so that is the point. So let's discuss a database. Now this is a theoretical part, but there are some keywords which you need to focus on. Okay, so a database is a very persistent way. This is a very important word. Way to store and access information that we need to go throughout the lifetime of our applications. So what does it mean that a database is something where if you have stored something, okay, it persists, it stays there. Okay, so it is not something that, okay, I put a data 3 years back in a database. Unless you yourself do something, that table or database will be available there always. Okay, so just like Newton's third law, that what is the third law, like I forgot here, but main point is, unless you do something, otherwise nothing will happen. Okay, so this is very important part. This is like, it does not degrade with time. So if you have a database, you place something here, that information will persist there indefinitely. Okay, it is a place where information gets stored on a hard drive. So remember, database could be on a hard drive, just like my laptop, right? So my personal laptop could be there. Okay, or it could be across cloud servers like cloud system, AWS, GCP, whatever you say. These cloud systems are called distributed, like distributed data servers. So basically they can be present on your personal systems, on cloud servers, or across anything. Now okay, and thing is that this particular part, the data is present in a very structured and searchable form. This is very important word here. Okay, because entire SQL depends upon that. Whenever, like when you, like those who have lived in hostels, right, they know, like in room, if you, for example, you put something there, in 15 days you might not find it, right, because your room gets so messy that you are not able to find it, right? So thing is not searchable in those scenarios. But a database is like that. If you put any information there, you can search it through indexes. Like we use SQL queries, right? Different databases have different methods, but main point is that anything that you put in a database, it is searchable. In SQL we do using SQL commands. In graph database we do using, there's SQL cipher query language. So every language has different part, but the main crux is that you can search that data which is present anywhere. Okay, anyone, any doubt on this slide? Any point which didn't come in your mind? Okay, pretty simple, right? I mean, it's intuitive, but we should know this. Now the point is that why do we need database? Okay, why don't we simply use files, we can simply store Excel files on our systems? Why don't we do that? Can someone tell me?
Bro, can you repeat again once?
I'm saying, why do we need a database? Why not we simply use the Excel file, CSV file? There are a lot of file formats. Why do we put everything in a database?
To overcome the redundancy of data
What do you mean by redundancy?
and the duplication of data or huge data, you can simplify by
Let's say I have my particular files. I store those files on my system only. That is not a database. So there will be no duplication. But still, why I prefer a database?
If it is in Excel, all the people can access it. If it is in a database, we can given some security reasons.
My Excel, I can put password in my Excel. I give access to myself only.
I guess because of the manipulation purpose, like, in a structured way, I can, I can just guess, like, in a structured.
The concept is of concurrency. Okay, whenever, if suppose you have opened an Excel file, until you close it, other person cannot use it, right? Have you tried this? Like if you try to open two versions, it says another version of Excel is already open, please close it, then only you can open this. These
Yes,
error everyone would have faced, right?
Yes.
That is what database is. That, for example, let's say you have a database here. Even if there are 500 people putting the SQL query on this parallelly, person 1, person 2, person 3, it will answer to each of them. This is called concurrency. See, we need the ability for multiple connections to be made to the database simultaneously. Okay, so that more than one person or entity can act at once. This is the major, like out of all these four, like we discussed about persistence and querying in the previous slide. Then comes concurrency, right? So that everyone can randomly query, randomly search results through it, irrespective. Like, does it ever happen that you write a SQL query, they say, oh, 500 people are already putting a query, please wait, then I will answer you? Do you see that thing?
No,
you don't see that thing, right? Now this is not a magic. This is how databases are built. Okay, now these things sound very intuitive to us, but just try to relate when you use an Excel, when you use something else, right? So these things happen. Is it clear? Any doubt, anyone? Okay, now next comes scalability. That as someone just mentioned on the chat, that to store large volume of data, Now, an Excel can only store 10 lakh rows, right? 1 million rows. It cannot store more than that. What in future, like I can go billion, million, trillion, like so many rows. So, I mean, as a normal Excel file or any other type of file will not be able to address that. That is the reason we need a database. Is it clear? So these four reasons are the four main points why you need a database. Persistence. Persistence means that it stays there forever unless you yourself change it. Querying, you can search once you put data in it, you can search it. Concurrency, multiple people can act simultaneously. And fourth is scalability. You can increase the database whenever your data size increases, you can scale it. Okay, all good? Anyone, any doubt in these 4 points? Okay, so we discussed this question, we already discussed. Now we are going to discuss every database which you see has some properties which are called asset properties. Okay, there's atomicity, consistency, isolation, durability. I'll speak about each of them. Every database should comply with the asset property. Any type of database that does not comply is not a database. Okay, so asset compliance is the first thing that you check whenever, because people create lot type, like you don't know, people create so many types of databases day in day out. Okay, but not everything is asset compliance. Okay, so we need to know this. What are these 4 asset properties? You would have heard somewhere, but how many of you know about this? Can you tell me? Anyone who knows about asset properties?
No.
Okay, so let's discuss one by one. So first of all, we'll discuss atomicity. Okay, so basically, what are atoms? Atom are the smallest part of a, like, let's say any living thing. For example, any human cell is there. They're the most smallest part. They have electron, proton, those, right? So there comes this concept atomicity in tables. In databases, what happens that once you put something, you basically communicate. Basically, you either send request or you ask something. So these things are called transactions. Okay, this does not mean money. It means that you are basically talking to a database. Okay, so a transaction is treated a single unit of your work. So whenever you talk to your database, you do in form of transaction. They are called transactions. Okay, or simply you call them query as well. Okay, you say that I'm querying a database. It means I'm doing some transaction with the database. It says that either all operations in the transaction succeed or none of them are applied. So what does it mean? So let us say you have a database. Okay, so suppose you have this database, account ID 1 and account, there are 2 people. You're transferring $200 from Rob's account to Marsh account. Suppose you have to write a SQL query for that. Okay, what happens? Suppose let's say Rob transferred $200 from his account to Marsh account. Something like that happened. In the back end, what happens in software system? A SQL query runs. A SQL query deduct balance from this, and a SQL query increase balance here. That's how things work in real. The digital money that we say, eventually what happens? A SQL query runs. So that SQL query will basically reduce 200 from this and add 200 to this. So this is a one transaction. Okay, so think of a transaction as single unit. Atomicity ensure that either the entire transaction succeeds or nothing. So what does it mean? That if during the process, suppose when you're transferring from A to B, suppose you deducted from A, let's say deducted from Rob, and then the server crashed. Okay, so will it happen that Marsh does not receive money? So what happened? Money deducted from Rob's account, but money did not reach Marsh account. There were 2 steps. First step was to debit from account A. Second was to credit to account B. Okay, this particular part succeeded. Okay, but this one failed. So once this scenario, this was your one transaction. Okay, so atomicity says that either the whole transaction will be completed or nothing will be done. So in this particular scenario, I see my first transaction is complete, first part is completed, but second part is not completed. So what will happen? The system will automatically restore itself to its initial position. So even if $200 were deducted from this, they will come back to Rob's account. Lot of time you have seen it happen. You send money, some server error comes, then other person does not receive the money, then again the money comes back to your account, right? You are ensured that either the money will go to his account or the money will come back to your account. That is the digital surety that we have when we do online transactions, right? This is called atomicity, right? So suppose March, this Rob person started the transaction, this transaction begin, the step 1 happened, step 2, and this is the endpoint. If during this phase, at anywhere, if my system crashes, I will come back to begin transaction. I will not proceed with any of this. Okay, is it clear? So this is the concept of atomicity, that either all operation in a transaction succeed or none of them are applied. Questions? Let me know.
Any syntax is there for this one, or just
This is syntax. This is a SQL code only. Okay.
okay?
This is not, no,
begin.
atomic. This is not a syntax. This is a property of your database.
Okay, so begin transaction, update
So we need to study SQL ahead, right? So what there's some transaction statement that okay, from here transaction begins, update account, set balance, so reduce balance by 200, right? From here we are reducing balance by 200, and here we are adding balance by 200. Okay, unless both of these are completed, the system will come back to the neutral, the starting point. Yes, it is going to be automatic. You don't need to do anything. So what does it mean? Whenever you write a SQL query, either the whole SQL query will be executed. For example, let us say you write down select star from table A, where let's say you put a filter A is equal to 30 and order by, let's say, B descending. Though either your whole SQL query will be executed or nothing. Does it ever happen that, oh, I gave you 3 columns, but they are not sorted because an error came in the system? Does something like that ever happen? Either you get an error before while running code that, oh, this code does not work, or your code works. Is there any middle ground that, okay, up to where condition code got executed and you got the table, but the order by did not work? Something, does that happen anywhere, anytime in SQL?
No,
right? This is called the concept of atomicity. Anyone, any doubt in this? So it is either all in or all out. This is a concept, all in or all out. Any doubt, anyone? Shall I move ahead? Okay, guys, please don't shy away from asking questions, please. Okay, now next topic is consistency. Okay, this is something that we discussed yesterday as well, that a database does not violate its own rules. So what does it mean? That, for example, you defined a variable salary int. Okay, so it will always, or whenever you see any row in the database, it will always be integer. So this is what it means, that once you have defined a state for a variable, it will follow that every time. Okay, it does not violate its own rules. This is the meaning of consistency. Okay, so whatever constraints you set up, they are valid for the entire database. There will never be an exception. Oh, For 99% rows, salary is integer, but 1% salary is character. Something like that will never happen. Okay. So one was atomicity, second is consistency. Okay. This is, I think, fairly easy. Now, isolation. So it says that multiple queries for transaction means SQL query, simple. Okay. They occurring simultaneously do not interfere each other. For example, there are two transactions going on in your database. Transfer $100 from A to B, transfer $200 from account A to C. These two are independent. Okay, they will not interfere with each other. So what does it mean? Suppose you write down select star from a table, okay, where A equal to 30. This is your one query, let's say. And suppose you have another query, select star from table where A is let's say equal to 40. They will never interfere. This will have a separate result, this will have a separate result. You will never get something, oh, A is either that you got a data set where you have 30 and 40 both. Those things you're not going to see. These might sound very obvious, but these systems have been built. Okay, they have been built so that we by default assume that these things happen automatically, but no, these are the properties. This is called isolation. Okay, without the isolation, these operation might mix up, causing incorrect balances in the accounts in this particular example. Okay, so this is called isolation. So we discuss ACI: atomicity, consistency, isolation.
Bro, can you repeat once?
What?
This one. Isolation. Yeah.
Isolation says that when multiple transaction, when like 100 people are there, 100 people are writing 100 SQL queries, right? They will not interfere with each other. So suppose a query 1 has a filter, let's say A equal to 30, and a query 2 has a filter A equal to 40. Both of these query will have separate results. They will not combine. That's what I'm saying. That okay, let's do one thing. One person asked for query A equal to 30, other person asked query A equal to 40. Let's do one thing. Let's create a single database where A equal to either 30 or 40. Does something like this ever happen in SQL?
No, bro. Understood.
Understood, right?
Yeah.
As I mentioned, it is very intuitive to us that okay, yeah, that makes sense. I mean, it should have, but no, systems are built that way. Try when you create these things, try to build your own data, create your own table, try to put these properties. You will realize these properties are not by default. You have to build this. Okay, so isolation is that property. Now comes the last part, durability. So as I mentioned in the start as well, once a transaction is committed, once you run a query, the changes are permanently stored in the database, even in the event of a power failure. That's what I meant, that once you put something, it stays there forever. Okay, it does unless you change it. So you just save an important document on your computer. Durability ensure that even if your computer crashes right after saving, the file is still there when you restart. Okay, this is what it means. Okay, so for example, we store our files on Google Drive or cloud servers. Do you know, for example, how does a let's talk about a Google Drive. We use it very frequently. Google Drive are scalable computers. Computer 1, computer 2, computer 3. These are present in data centers of the company. Okay, like this. When you store a file, for example, I store a file in Google Drive. Now Google Drive will access whichever place is free. It will push your file to that particular computer. You will never see that where my file is going. You will only see, we only see that okay, my file is at Google Drive, and whenever you want to access, you are able to access it. But what is happening in the backend? Google Drive puts it into one of the available servers on the computers. Okay, now whenever you want to access it, you are able to access that file through Google Drive. But eventually these are computers only. What if this computer, let's say you save the file, Google Drive saved your file in computer 6 and computer 6 failed. Does it have ever happened that you are not able to see your file? Because computers fail every day at big companies or anywhere, but they have built the system so smart that even if my system fails, you still are able to access the file. That is the beauty of it. That is called durability. Okay, any doubt, anyone? Yeah, this is called cloud. Yes.
And Sadhvik, like in Google Drive, if I'm accessing my file, so
Yeah.
it's also depend on the geo location wise also, like on which
Yeah, of course,
server my file will be
right? For
available.
example, yeah, like for example, if I'm using from US, right? So in US, Google will have multiple data centers, right? They have data centers. So my file might be stored somewhere there in some of the location of US. If you're saving from India, your file will be stored somewhere in one of the computers of India. You will never
And
be able
so
to see that.
and that also increase the access file, because if I am accessing from India and the server is also available in India, then the accessing of that file will be fast. Is that also correct?
Yes, I mean, of course. See, if I'm connecting through it, I'm in US. If I connect through an Indian server, there will be some lag. Okay, latency. That is called latency. But that is very minimum. I mean, these companies have built the system so strong that those minute differences you are not able to see. Okay, so for example, when I open Netflix, okay, Netflix data is stored somewhere. It's right. It has to be stored somewhere. So for me, it will be stored somewhere around my near my city. Let's say uh, Netflix has some data center near my city or something like that. So I will get that signal from there. Okay, just like how mobile towers work. You have a mobile tower near your house, right? You get the connection in your mobile through your nearest mobile tower, right? That's how these things also work. Okay.
Okay, thanks.
Is it clear? Anyone, any doubt? So these are the four properties, ACID properties you should know, because people ask every time that is my database ACID compliant or not. So you need to ensure all this thing. Okay. You will not to write the codes on your own, but I mean, you need to know whether my database is ACID compliant or not. This is the first property of any database and the most important property. Okay. And anyone, any doubt? Yeah, of course, these are very costly. That's why they charge a subscription. Like, uh, okay. So we discussed about this particular thing, right? So four properties we discussed: atomicity, consistency, isolation, and durability. Now let's discuss how a database work. So these are database work. Again, there are four more things: crude operations. These are called crude operations. So they work on create, read, update, and delete. These are the four major statements for any data, which will exist for every database. Create, we know for SQL, right? Read, what is read? We write down queries that select star from this. That is a read statement, that I have a database present, I am reading from it. Select star from my table, that is called a read operation. Update, suppose I want to update any data. Delete, I want to delete any table. So these are called the crude operations. Okay, you now, if you don't know they mean these, you will get confused. What does it even mean, crude? Right? It's just a short form for all these, that every database should have these properties. First were ACID properties. Okay, these are properties. And second, database should have crude operations. Okay, these things are mandatory. So how do we interact with databases? We typically send commands or statements to our database, right, to do things. When a statement returns a set of records, we say it a query, right? most like these it's fine, you can skip this. Like all these happen via API call. Like we just write down a query. What is I didn't get your question.
So, Satvik, as you had mentioned, crude operation. So, they also being considered as DDL, definition language, or data manipulation language.
Yes.
Okay.
So yeah, so basically these are your DDL. One is data definition language, right, where you basically define, modify, or like delete your databases. You do that in DDL statements, and your other is like data manipulation. So those are included in this.
Okay. Okay. Got it. Thanks.
Okay. So basically, what are your data definition language? So there are two types of languages, which we say data definition language. So these are what they are basically used to create or delete. Suppose you have to delete something, so they are called data definition language. Okay, so for example, create commands. And next comes your basically data manipulation language, DML commands. So these are like insert, update, those kind of statements which we use. Okay, so now let's move to the main topic, that is data modeling. So we are going to discuss below topics. First is entity relationship diagram, relationship database versus non-relationship database. Okay, then primary key, foreign key, cardinality, normalization, star schema, and snowflake schema. So these are the topics for today. So how many of you know, like which all topics do you know? Have you ever heard of? Can you tell? Out of these 8. Guys, this is a theoretical concept, but you should know it. I mean, it's very important, I'm telling. Okay. Okay, so let's discuss. Okay, most of you have heard somewhere, but still let's try to define each of the method, each of things, and so that it stays in your mind. After today's class, make sure you know all this by default. Okay, so that is something expected. So entity relationship diagram basically is a, I'll say, so before this, I'll discuss other things. Then I'll come to ERD towards the end, because I need to discuss cardinality and foreign key, primary key. Then ERD will make sense. Okay, so I'll come to this towards the end. First, discuss about relationship. So relational databases and non-relationship databases. So can you think and tell me why we call it relational, why we call it non-relational? What is the difference? Without looking at the PPT, tell me, what do you know about relational databases, non-relational databases? Relation between tables. So for example, NoSQL, which is a non-relational, is there no relation between them? You're going right. You're going right. I'm not saying you're not right. So tell me, what is the meaning of relational databases here?
Relation database means it is in tabular form.
Okay.
And it is
Just
structured
having
and
having it
organized.
open sufficient to call a relational database?
Mainly, we have a common columns so that we can have any relation between two tables.
Yes. So the difference, let me tell you, the difference between a relational and non-relational database is that all the information which is present, for example, let us say I talk about an e-commerce platform, they will have lot of data, right? It will not be just one data. For example, e-commerce will have, let's say, orders data. They will have customer profile data. Okay. Then they will have, let's say, so order status we discuss, customer, they'll have payment data, payments. Okay. All of this. So what do we do in relational data? For each of the categories, we create different tables. Okay. Table 1, table 2, table 3, and then we try to form some connections between them, that okay, basically a customer will make a payment, all right? Once a payment is completed, then the order will be dispatched. Okay, there is some logical order, and this is how the table will also be defined, that okay, so tables are not just random tables, they carry a meaning as well with reference to each other. But when we define a NoSQL database, what happens that everything, let's say, is present in a JSON. It does not, you can have hundreds of variable values here. You do not perform like those joins which we do here, which primary key, those concepts do not lie in the NoSQL. This is just a place where you have dumped the variables, okay, without having any relationship between them. That is why most people ask that the dashboards that you build, Power BI dashboard, the analytics that you do, everything is on a structured data. Why? Because there is a proper relationship between tables which you can utilize, which you can use while building dashboards or doing analytics, doing any kind of thing. And this kind of JSON data you need maybe like you need for other purpose. I mean, relationship is not important in those cases. Okay, suppose I just want a customer's let's say customer's IP address. Okay, now there I do not need to know the order for all, like how these tables are related. I really do not need to know, because all that information is present here. I'll simply plug in. Okay, we'll discuss, we'll build more on this. Okay, so relation databases organize the data into tables where relationships are established between tables using the key. So there are two types of relationship which exist, where there's a primary key and a foreign key. So let's say we have these tables: students, instructor, enrollments, and courses. So what kind of relationship is there? A student will enroll for a course, right? And a course will be taught by a tutor, instructor, right? So a student will enroll in a course, and a course will be taught by an instructor. So if you see, suppose, let's say I see these two tables. This table, of course, I have not discussed primary key yet, but I will discuss them. But based on your knowledge, we have student ID, student names, gender, and date of birth. I have student information from here, and I have enrollment. Now, for in an enrollment table, I need to know who enrolled, right? Otherwise, let's say I have enrollment ID. I need to know whether, like, which person enrolled for this. So these two tables will be carrying a relationship, that they're internally connected. That's why you do joins and all that, which are present there. Okay. Similarly, these two tables are also connected. Okay. Now, these two tables might not be connected directly. Student and instructor might not be connected directly, but through this order, like S is connected to E is connected to C, and I is connected to C. So this way relationships are established. Okay. Any doubt, anyone? Graph database is a relational database. Graph is the biggest relationship database. There you define, so here we define primary key, foreign key, right? In SQL we do primary key, foreign key. In graph database we do entity and relationship. We talk about that. So remember I showed the graph database yesterday. I talked about entities, I talked about relationships. So yes, relationships are there in graph database as well. So they are also a relational database. No, graph database cannot be stored in NoSQL. Graph database is a separate database. NoSQL is a separate data, like your MongoDB, and they are separate database. SQL is a SQL in. So for example, you cannot store a SQL table in a. For example, you cannot store a SQL table in a graph database. You'll take the SQL table, you'll convert it into into an Excel or CSV file, then you will push it into a graph database. That's how you interact with it. Okay. Yes, relationship database can be both structured and unstructured. For example, the the graph database, there's no structure to it, right? So that is a kind of unstructured data, but that is also, there also relation, there is also relation in the graph database. Okay. In the SQL, which is a relationship database, there is a structure there. So it can happen, it cannot happen, depends upon. But thing is that in graph, you define only entity and relationship. Okay. So that's how you are able to segregate the things. Okay. So that is a difference. So a relationship database, relational database can be both. Yes. Any other question, anyone, before I move in? Okay. So let's discuss about primary key. Okay. Now this question is that a primary key is a column or a set of columns, okay, that uniquely identifies each row in a table. So let's do one thing. Let's go to the Excel. So this is a table. For example, customer name, email, and phone number. A primary key is that column in a table which is, it has two properties, remember, which I just showed you. So it must be unique across all rows. This is the first property. It cannot be null. Okay. And it ensures each record can be identified. So it should be unique across all rows. It cannot be null. So let me show here. For example, this is here. So here we have a customer ID, right? So customer ID, if you see, this is unique, this is unique, this, everything is unique. And each customer ID depicts a different customer. Okay. So therefore, this is the primary key. Now you might be saying that I have names as well different. Why not name is my primary key? Why not my email is a primary key? Why not my phone is a primary key? Because phone numbers are also distinct. Customer IDs are also distinct. So tell me why customer ID is a primary key? Why not name is a primary key? Why not email is a primary key? What do you think? There
Maybe
can no, I haven't reached to candidate keys yet. So yeah, try to answer.
maybe,
Yeah,
maybe the other table does not have the same
I'm just
column.
talking about this table. Why do you bother about other table?
Okay.
What is the criteria to be a primary key? First, it
Must
should
not be repeated.
not be null. Okay.
Not null.
Unique.
Distinct values.
Yes.
Right.
Yes.
These are the two criteria. Okay. Now let's talk about this. There's a person named as 𝗗𝗏 Sharma. Okay. Can there be another 𝗂𝗻𝘀 in the world?
Yes.
There can be an 𝗂𝗻𝘀, right? That's why name, this is not a name can be a blank. For example, you can say there was a customer, but his name is missing. So can this be a null? This can be a null, right? So this violates both of the condition. It can be null, and it can be, for example, uh, multiple people can be there, right? So it is not distinct. That's what I mean. Same goes with email. Same goes with phone number. But two people, like, for example, two people in India cannot have the same Aadhaar card number, or two people in US cannot have the same SSN number. SSN number or Aadhaar are unique. Name can be same, right? Do you get this point?
Yes.
Anyone, any doubt that why these three are not primary key and why customer ID is a primary key?
Yes. Like PAN card.
Why PIN number? Like zip code can be same for two people, right? In a single sim, in a single area, multiple people can live. Email can be unique, but no. But what if two people are sharing same email ID? No. What if, let's say, you created an email ID, the email ID expired. Okay, then you have a new email ID. Say, so two people, one email ID is expired, another is not, right? Let's say I created two email IDs, s@gmail. I created it 10 years back. It got expired. Someone else is using it now. So two people can have same ID. One is active, one is not active. Plus, they cannot be, they can be null. Email can be null. Phone number can be null. A person may not have phone number. A person may not have an email address, right? So, but a person should have like in India, for example, or US, a person should have an SSN number. A person should have an Aadhaar number. A person may not have a phone. A person may not have an email. A person may not have money, but he should have this, right? If the person does not have Aadhaar or SSN, generally they are treated as illegal people, right? So that's how things are done. So do you get the concept that why this is a primary key, why these are not? Any doubt, anyone? Okay.
No.
Now tell me this. Can a table have two primary keys?
Yes.
We have it.
How? Tell me, give me an example.
Maybe not. Don't know, bro.
Think and tell me. No, 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 no. So do think, do search a little bit on this. Okay. This is an open-ended question. Okay. Let me know what you guys think. I'll ask this question in the next class. Okay. Study about, read little bit online on this, that what is a primary key exactly? Does it make to have sense multiple primary keys or not? Okay. I'm leaving this. Yeah, there's a concept called composite key. Okay. Where, for example, a single table might not have so what you do that it may not have one primary key. What you do, you combine two variables. So what you say that, okay, name and email, you create the same combination, you concatenate them. Then you say, okay, this is my primary key, for example. But do one thing, study about this. We'll take up this question in next class. I want you guys to explore first before answering. Okay, so take this. I'll ask this question in next class. So search about this. Can a table have two primary keys? Okay. Now let's move towards the foreign key. Foreign key is a column in one table. It says that it's a column in one table which okay. Yeah. It's a column in one table that links to the primary key in the table. So that this is very important. Column in one table that links to the primary key of the other table. That's how relations are established. So it ensures referential integrity, which I will tell in next slide. It can accept null. So remember this thing. A foreign key can. So first of all, let's understand what is a foreign key. Let's say these are two tables, student and enrollment. Okay. So there is one of them will be a parent table, one of them will be a child table. Okay. So which of these so if you see this student and his enrollments are there. So these both tables have this particular student column. So this also a student column, this also a student column. Tell me which one is primary, which one is in which table is it primary and in which table it is foreign key.
So basically in the first table, it's a primary key. And in the second table, the student ID is the foreign key.
Yes. So in the first table, what is the primary key? Student. The first table is built on primary key student ID. And in the second table is built on the primary key enrollment ID. But in second table, there is a mapping key student ID, which maps to the student ID of my main table. So this is called a child table. Okay. And this is called a parent table. Okay, so this will map with this one. So in this, so whenever you will be defining these two tables, you will have to mention that this variable is a foreign key to this particular table. Okay, is it clear? The concept of foreign key. I think most of you already know, but still, how two tables are mapped, on what variables are they mapped? So so a foreign key will be mapped on your other tables primary key. Okay, that's how it is. Mapping is done. Now
Bro,
let's.
you have
Yeah.
mentioned a foreign key also twice.
Where did I mention foreign key twice?
Here, course ID, foreign key.
Course ID, I didn't. I just said student ID is a foreign key to this. Course ID, I didn't say is a foreign key. Yeah, foreign key can be duplicate, but here foreign key is not like, what is a foreign key? Which is a primary key in the other table? Out of these four variables, tell me which variable is the primary key of my main table.
The main table is having student ID.
Yeah. So which of these contain the which is the foreign key in this?
Yeah, second column only, like student ID.
Yeah. So course ID, I never said course ID as a foreign key. Course ID cannot be foreign key to this, but it can be foreign key to some other table, not this table.
Okay. Okay, that's not related to that table. Okay, bro.
Got it?
Yes.
Anyone, any doubt on foreign key so far? Two tables are joined based on foreign key only. Otherwise, how will you join them? Can you join two tables based on primary key? Let's try to visualize this. Okay. A good question you asked. Let's do one thing. Joining happens on foreign key. That's the concept of foreign key. But still, let me show you. So suppose you have, for example, one table student ID. Okay. And let's say his name is there. So let's say student ID is 101, 102, 103, 104, 105, 106, 107. And we have some names, for example. Now I have, this is my table 1. And I have another table, table number 2, whose, let's say, whose primary key is course underscore ID. And course ID is one, is, let's say, 1, 2, 3, 4, 5, 6, 7. Okay, let's say course name. This is the variable name. Now tell me this thing, can you join these two tables? Tell me this. Can
No,
you,
bro.
why?
We can't. We can't.
We cannot, because there's no mapping variable, right? So join only happens on foreign key only. Remember this. Join can never happen on primary key. Primary key is for this table. This primary key is not primary key for this table, right? So join will be happening based on foreign key only. Okay. So unless we have a variable that maps these two tables, we cannot join them. And that mapping comes from a foreign key. Is it clear?
Yes.
Someone was asking a question, can we join two tables based on foreign key? My answer is you can join only on foreign key, nothing else. You can have infinite number of foreign keys in a table. So let's say I have this particular table. Okay. This is a table, table 1. Now there can be 100 tables in the outside there. Okay. T2, T3, T4, T5. Now let's say one column is foreign key. It is foreign key to this table. Another column is foreign key to this table. Another column is foreign key to this table. Another column is foreign key to this table. So there were 4 columns. Each column a foreign key for a separate table, right? So there can be unlimited number of foreign keys in a table, but there can be only one primary key. But explore the primary key thing, but foreign key can be multiple.
Excuse me, sir.
Yes, please.
Sir, in the previous example, you have told you named given a name and course name. How can we join that to? Suppose is a name is a foreign key and course name is a foreign key. How will we join them?
We cannot join these two tables right now. That's what I said. We cannot join these two tables. If I have to join them, I need a variable which map these two these two tables. That's what I said.
Okay, and in a table, how many primary key can be there?
That's what something I have asked you guys to explore. Again, give me the answer next week.
Okay.
Okay. There can be multiple foreign keys for sure. Okay. But there can there be one foreign primary key or multiple primary key? That is something you need to tell me. So explore this. Okay. Is it clear to everyone? Foreign key. Okay. So let's move to the next part. So next come for foreign key referential integrity. So what does it mean that now let's see, we have these two tables, right? So the left table, so department ID is a foreign key. Okay, this is a foreign key to this particular. So we have employee IDs, and for each employee I have departments. Okay, and this is my table B. This is table A. Now department ID is a foreign key. Now see, foreign key can be null first of all. Okay, so I'm going to read three conditions. First of all, department ID 1 is valid because 1 is present in this foreign key and it is present in the main table as well. So it is valid. Your foreign key can be null for some of the places. Remember, primary key cannot be null. So, for example, for this particular person, department ID is null. Foreign key still holds, but their relationships becomes optional. Okay. So foreign key relationship is optional and it can be null. This is the primary thing. And the most important part, suppose this is your primary key, this is your main table. Here department ID contains only three values, 1, 2, and 3, these three values. If your other table contains a different department ID, for example, 5, it is not possible. It will give an error. So if an employee had a department ID equal to 5, it would violate the referential integrity because 5 does not exist in the department table. So in the parent table, all the distinct values should be present. If it is not present, then means that is not the foreign key, that relationship is not correct. This is called referential integrity. Okay. Any doubt, anyone? So what do I mean to say through this slide is that your foreign key can be null, first of all. Second, your parent, all the foreign keys which are values which are present in foreign key should be present in your main table. There can never be a value in a foreign key which is not present. For example, 5 here, okay, which is not present in main table.
Bro, please repeat, bro.
Okay, you tell me what did you understand?
Not understood, bro.
First, I told there is a table. Okay, this is a foreign key.
Yes.
And this is the main table.
Yes.
I said that null primary key cannot be null, but foreign key can be null. Is it clear?
Yes.
Second point. Now tell me, this is your child table. This is your parent table, right?
Yes.
Which all value department ID is having in the child table? 1, 2,
1, 2, 3.
and null. 4 values. Correct?
Okay. Yeah.
Okay. If you ignore null, are all these 3 values present in the main table?
Yeah, parent table.
They're present, right?
Yes.
But what if in this table there was another row which contained a department ID 5? That is so that's what I mean to say, that is not possible. Okay. It means that all the distinct values in any foreign key, for example, what do I mean by distinct values? Like 1, 2, 3. There are 3 distinct values in the foreign key. They should be present in your parent table. There can never be a value which is not present in this. No, query will not run. So whenever you will, so what will happen? Let me tell you. When you will create table, okay, we will see that while I create table. Suppose you declared, in the query you wrote that department ID is a foreign key to this table. And if you insert a new row where department ID is 5, it will throw you an error, foreign key error. No, for null, foreign key does not create an issue. If there is a null, foreign key, foreign mapping becomes optional. That's what I mentioned. Relationships are optional. So null does not create an issue. Your foreign key can have null. Null has no problem. But the problem is it cannot contain those values which are not present in my parent table. Is it clear now? Or everything is going above your head? Guys, yes, no, please respond at least. Is this concept clear? That the referential integrity.
Yes, bro.
So it says that foreign key can be null, first condition. Second, foreign key cannot contain those values which are not present in your parent table.
But 104 also it's not there, right?
104 is not a foreign key.
Okay,
Where
okay.
are you lost?
Oh,
These two tables. What is the foreign key for these two tables? Tell me.
okay, got it, bro. Got it. Like foreign key
Department
is
ID.
department ID.
You need to get department ID only.
Yeah, got it, bro. Means reference is not there under the parent table. Like
Yes. If for department ID any reference is not there in the present table, means it is an incorrect. So what I mean to say that if you try to enter a row, if you try to create a row that insert into employee ID where department into 5, the query will give you an error.
Okay.
All clear?
Yes, bro.
Okay. Now let's move to next topic, cardinality. So there are three types of relationship between tables: one to one, one to many, and many to many. Okay. You guys, most of you know, but let me show you what does it mean. So one to one means that each row in table A is related to exactly one row in table B. So for example, and remember vice versa, it should be true both ways. So these four, table A exactly one row, table B, and vice versa. So for example, this is a person table and this is a passport ID table. Okay. Each person, so for example here primary, each person has exactly one passport. If you see that, right, in this particular table, each person has only one passport and each passport belongs to exactly one person. Okay, so this is called a one-to. So when we try to relate these two tables, we will say that these two tables possess a one-to-one relationship. This is a person table, this is a passport table. Okay, so a person can only have one passport. Okay, so if you see this one, and a passport can also, like, this is not possible that passport ID is 101 and person ID is 12. This is not possible, right? So this is a one-to-one relationship. Can we delete row from the foreign table? Yes, you can delete row from the foreign table. Yes. Is this clear? One-to-one relationship.
Yes, bro.
Next, do one-to-many relationship. Okay, so a single row in table A can be associated with multiple rows in table B. So basically it is one, so it will go like this. It is called like this, one to many. Okay, so this is table A and this is table B. So this is in one direction, remember. So table A to B, one row can be associated with multiple rows. However, a single row is associated with only one row. So back forth is not. So what do I mean to say? If A has one to many relationship, it does not mean that B also has one to many relationship. Okay, this does not hold. For example, department and its employees. So we have a table department and we have employees. Okay, a department can have many employees, correct? A department can have 100 employees, 200, 500 employees. But can one employee have multiple departments?
No.
So for example, this is finance department. Finance department, there's
Not
HR
possible.
department, there's data science department. Okay. In finance department, there are person 1, 2, and 3. There is person 4, 5, and 6. There's person 7, 8, 9. Okay. This person 3. So finance has 3 connections. It has 3 people. But one person can only have one department. It cannot have 3 departments or more than 1 department. This is the meaning of one-to-many relationship.
Bro, how can we estimate like which is one to many and many to one?
You will need to do joins and check that.
What?
You will do left join and then check that.
Okay. Okay. Okay.
Okay. But just by looking at the schema and your basic knowledge understanding, you will be able to relate whether it is a one-to-many. For example, can you guys give me some other example of one-to-many relationship?
Yeah, courses and what is this?
What?
Like we joined in SQL, right? You
Yes.
have many Python and SQL, Excel, many are their courses.
For
We
example,
joined,
let's say, for example, data science has 3 courses: SQL, Python, okay, let's say Power BI, for example. You guys joined in the SQL course.
yes.
You are in the SQL department. So right now, do you have any other department? No. Correct. So that is like whenever you join a company, you join in one department. You do not work in multiple departments. Like course, you can still buy multiple. So this is not the right example, but think from company perspective, right? You either, for example, you either work in finance, you either work in HR, you either work in some other, right? It is not possible. In college, suppose you are either in a computer science department, you can either be in electronic. You cannot do computer science and electrical engineering both parallelly, right?
Yes, bro.
Is it clear?
Yes, yes.
So is one-to-many relationship clear to everyone?
Yeah, bro.
Okay. Now comes many-to-many relationship. So again, what will be there? For example, student and the courses. A student can enroll in multiple courses. So what the example that you gave for the course was actually many-to-many relationship. A student can enroll in multiple courses. For example, you are a student A, you can take a SQL course, you can take a Python course, you can take an AIML course. Okay, right? Now each course can have multiple student enroll as well, right?
Yes.
It is not that okay, one person enrolled for AIML course, only one person will be there. Multiple people can enroll, right? So see, this is the key, that you have course table, you have student table. So when you match them, you will see that okay, for single enrollment. So if you see single and 1, 2, 3, 4 enrollment, there are multiple courses. Okay, so 2 people, these 2 students, okay, they have different courses, right? And these 2 course IDs 101 and course ID 1. So this course ID 101 and course ID 101, it has 2 people, student 1 and student 2, right? So the course, if you see, course 1 has 2 people, course 1 has 1 and candidate 2, correct? And also candidate 1 has taken 2 courses, 101 and 102. Yes, orders and shopping website from a customer, correct? So these are the 3 relationships which exist in databases. Pretty intuitive, I think. You will realize, so these will come handy. We will discuss them in more detail once we do joins. Okay, right now just understand that these are the concept, how to actually decide. Someone was asking, how do I get to know which type of relationship exists between the tables? For that, we will use the concept of joins. Okay, so we'll study the cardinality in more detail there. Okay, so now we discussed about this. Now, so next comes normalize. So we have 2 concepts left: normalization and the schemas of the table. Okay, so first of all, let's so this is a database with you. Can you guys look at, just don't look at the yellow thing, just look at the data. Tell me what are the possible potential issues with the database. Can you guys think?
Means, bro?
There are multiple Data about customer ID.
There are multiple what?
Multiple values on customer
Duplicates,
ID.
duplicates of customer
Multiple
ID.
No, but let's say the data is transaction data. The primary key
I
for the
think
table
it's
is transaction.
quantity. There is a problem.
Okay. What is the problem with quantity? So this table tries to imply that the person ordered one smartphone, okay, and two headphones. This way of representing value is incorrect. First of all, this is the first problem. Any other problem with this? Okay, let me explain you from the scratch. Okay, let's go to normalization. So let me just copy this particular data somewhere.
Hmm.
Okay. So this data consists of transactions. Okay, customer doing multiple transactions, and we are storing. One issue we saw that, for example, we cannot store values like this. That okay, one column has multiple. So like basically two rows are combined in one column only. First of all, that is not possible. This is the first problem. Although data can be, I'm not saying data cannot be stored like this, but this data is not ideal for us. Okay, so this is the first problem. Second, if you try to think that what is happening, suppose if you let's look at this customer 101. Okay, whenever he does any transaction, so this is customer 101, 101, and 101. Right now there are only 8 rows. Eventually there will be 8 million, 8 billion. There can be 8 billion rows. A customer can do hundreds of transactions. Just look at the variables and tell me, are there any redundant variables? What do I mean by redundant? Which basically which even if they are not present in the data, it will not create any big difference.
And customer ID and customer name, like we can remove either of them.
Why? Customer ID and customer name, they both are important.
Because that ID is representing that customer customer only. So uh, any one of that value will serve the purpose. Like any one of the column will serve the purpose.
But how will you get to know the customer name if the customer name is not there?
Customer name is not that important for the data in the sense.
Okay, I accept it. Okay, any other redundant variable? So look at this way. Customer name, email address.
Address is not required, I think.
Yeah, customer name, email address, and address. Look at these three variables. For example, this customer did 8 million transactions. Customer 101. Every time these three columns will be populated, but they will have the same values. Customer name will not change. Customer email ID, assuming that it's not changing. Customer address, assuming it's not changing. Right? So what is happening in case of 8 million rows? You are adding these three these values redundantly again and again, which is, although there is no issue. Like for example, you created a master data, but if you see this information is redundant, it is important, but you can, I mean, uh, every time, for example, whenever you want to update this row, 8 million times you copied this information. Remember, these three things you copied 8 million times in the database. It required compute power, correct?
Yes.
Compute power, space, time, and all that. Your right now there are only 7 8 variables. What if there are 30 40 50 100 such variables? It will involve lot of compute issues. Is it fine, everyone?
Yes. Yes, bro.
Now think that, suppose you decide that, okay, I have to change the email. Customer has changed his email address, or customer has changed his address customer changes his address at some point of time. You'll have to come back to this 8 million records and change all the 8 million records. Is it right? Yes or no?
Yes, bro.
Yes.
That's correct, but like suppose we have to deliver the order, then we have to do it. Like we have to retain the address.
I'm saying if customer changes his address.
In the sense, like if the address is changed, then again we have to like come back to this place and have to update here.
That's what I'm saying. If customer changes his address, you will have to come and update his address again and again, right? That's what I'm trying to say.
Yes.
If customer changes his email address, you will have to come to all these 8 million records and change it. That's what I'm trying to say. Okay. So this is called redundancy. Okay. Uh, so that's what we say, this data is not normalized. So let's now go to normalization. Let's read about a little bit. I will take 15 minutes, at least 20 minutes more. So like just to let you know, because like we started it 10 minutes late, that's why. Okay. The normalization is the process of organizing a data in a database to reduce the redundancy. Now, do you understand what do you mean by redundancy? Avoid storing duplicate data across the tables. Is the first point clear? Second point is very generic, it's fine. Third, avoid anomalies. What do you mean by anomalies? Prevent issues during insertion, deletion, or updates. So what does it mean? That, for example, if I have to just update one value, I should update it at one place only. I should not be updating 8 million records. That's what I mean to say. Now, for example, let us say there are 8 million customers. You want to change address for or something like that, right? Eventually the load becomes too much. So many redundant activities you will be doing. Okay. So basically this data is not, I mean, data is good, but we have to transform it, transform this data. Okay. This transformation is called normalization of the data, where data is not in its best form. Yes, there will be customer table. I'll speak about it. So basically we are going to we have to we have to perform some operation so that our steps are minimal, that my database is optimized. So first problem is this one, second problem was this one. So there are 3 steps in which we do this. Okay. So the first thing was that non-atomic values. The product column contains multiple items. For example, smartphone, headphone, it contains 2 items, right? Smartphone, headphones. This is called what is the meaning of atomic non-atomic values? Means atomic value means each one column one value only. Okay, that is the meaning of atomic values. Right now, product column is not atomous, like it is not atomic, because it is having two values inside it. Similarly for the quantity column is also not atomic, so we need to update this. Okay, and second is redundancy. There are two issues in this database which we just discussed. Okay, first is non-atomic values, second is redundancy. So we will be sorting this in 3 steps. So they are called first normal form. So basically normalization, this is called 1NF, first normal form of the data. So what do we do in the first normal form? The definition of 1NF says that first of all you need to sort the atomic values. It says that each cell must contain a single indivisible value. Okay, so what do we do? So now see what I have done. Can you read this to? I have split. If you compare with the previous, here I had these two in the same row. Now what I have done, I have split them into 2 rows. Okay, so now if you see each of the column is atomic now. Is it clear? What did I
Yes.
clear? So in the first form you do atomicity. Okay, there should be no repeating. It means that each of the columns should contain only one value.
I have a doubt. In that case, transaction ID like primary key is repeating.
Yeah, so that we will sort. There are 3 steps. That's what I'm saying. There are 3 steps. This is the first step which you do.
First one is atomic values, right?
Atomic values.
Atomic values.
So once you solve this, then you get transaction ID, which as someone mentioned that it starts repeating. We will sort that as well in future. Okay. Second step. Okay. This thing now, but still in my data there is redundancy. So what do we do? Eventually, the summary of this is that we break the data. Okay, so we take the data and we break it to, for example, these redundant values were there, right? Customer name, email, and address. So what did we do? We created a separate customer table out of this. Okay, we created a separate transaction table, and we created a transitory table, something like that. We created. Okay, now this has still issues. We will sort that in the next step. So the first step was to solve the atomicity, that is called first normal form. Second normal form is when you basically get rid of redundant values and you break into multiple tables. And third normal form is when you break so basically what happens that you break it into multiple. Now this transaction ID is no more your primary key. Remember this. Okay, now you have created different tables. So this is your product table, this is your transaction. This becomes your primary in this table. This is the primary key. Okay, right now there is no primary key here. So there comes the concept of compound key. Someone was speaking that you combine 2 values and then call it for example, one smartphone. You will concatenate these 2 variables, they will become a compound key, but that is separate. So the first step in normalization is to solve the atomicity. In second step is to break the redundant pairs, bring them into different tables. And third step is basically, it is called transitional redundancy. What do we do in that? We check for a primary and foreign key mappings and we create tables like this. Okay, so there was the issue of this. To solve this, what did we do? We created a transaction table in which we put overall transaction value as a single value. Okay, and that's how these tables are created. Is it clear?
Yes, bro.
Anyone, any doubt in this? We cannot stop at 12. Remember, see, we can I mean that we can stop at 2NF. It depends upon your data. Okay, we can stop after 1NF as well. Totally depends upon your data. Okay. If your data contains, there were a lot of type of issues which is not in the scope of this particular class. So that's why it was, so up to 3NF things are present there. But you can stop at any level. It's up to you. Okay. Clear, everyone? Any doubt? Let me repeat. In 1F, what we do, so remember, this was my main table. PPT is already present in the drive that I shared. It is present there. You can check that. The link that I shared, it has the PPT. See, this was my main table. It had two issues. First of all, one column had multiple values, which is not possible. Okay, this is the problem of atomicity. And then we had redundant values, which are not required. So I had two issues. 1F says that first solve the atomicity. So what did I do? I broke down the first row into two rows. Okay, which created different rows. So first step is to solve the atomicity. Second step is to solve the redundancy. Okay. Third step, you create transitional tables. You will not understand it completely, but just try to understand that after 2F, you do further optimization so that you create a final set of tables. That's what you need to know. You will not need to do these things on your hand. You should know that whether your data is normalized or not. That's something you should know. Okay.
Bro, under the second form, you said we will create the tables also.
This is the table.
Oh, yeah. Only remove the duplicates only, or we will create tables also?
This,
Both.
what was the table after first step? This was the table after first step.
Okay.
What is the table after second step? These three tables are there.
Okay. Okay. And last third one is for checking primary and foreign key, right?
Primary foreign key mappings. There are a lot of concepts there, but just try to understand that it is further optimizing and creating the getting like solving the redundant pairs. It is like that.
Okay. So we are having 3 steps total, right?
As what you need to remember is what is normalization. First of all, you need to know this. So what is normalization? That your data is not in the best format. So there are two major issues. First is atomicity. Second is redundant pairs.
Redundancy. Yeah.
Redundancy. So in these three steps, you solve them, and that's how you broke a data like this. Data was this initially, but this is not the ideal format. You basically bring it down to this level. Okay. You won't need to do 2NF, 3NF. Don't worry. It's just a theoretical concept that you should know. Okay. Everyone good with it? Any doubt, anyone? They can be asked. I mean, if you're giving a database interview, data engineer interview, it can be asked. For a data analyst, it won't be asked. If for data scientist role, it will not be asked. But if you're giving a database interview, then it will be asked. Okay. See, don't even what I'm saying, just know what is normalization. You don't need to dig in deep. What is 3NF? What is 2NF? Don't know all that. Just remember, normalization is a data which is redundant. I have to make it optimal for storage.
Yeah, simplify.
Simple. Yeah. So I have to basically make the data optimal for my storage, because see what will happen now. Now, if a person has to a person will just need to update his email address or address here at once, and the whole system will be resolved automatically. You do not need to copy his name or email address 8 million times now. Just update at one place and everything is automatically sorted.
Yes, understood.
Okay, so this is what is called normalization, that you bring a complex uh, non-optimized data to an optimized form. So you basically split it into multiple tables. That's what it is. Okay, any doubt, anyone, before I move to the last concept for today?
Mhm.
Okay, so now moving to the last concept, which is fact table, dimension table. So what is a, so there are two types of table in your system, in your databases. One is called a fact table, other is called a dimension table. Okay, I will tell you the most intuitive form. Fact table is something that changes frequently, every day, every month. Okay, for example, sales. For example, let's say money in your bank account. It keeps on changing very frequently. Okay, so let us say this information is there. Okay, stock. So a fact table contains a quantitative metric, basically, which keeps on changing regularly. That is called a fact table. Okay, for example, total sale, it will keep on changing very frequently. And what is a dimension table? Dimension table is just an information about that. So let me show you what do I mean by fact table and dimension table through the Excel that I am having. So if you come here, schema, so this is a fact table. This is important. This is as an interview. Almost this has been asked to me so many times. Difference between fact table, dimension table. So uh, fact table is that data which keeps on getting updated very frequently. Okay. So see, customer ID, product ID. This is a sales fact table. Okay. But what is a dimension table? That for example, customer, where we have customer information, just like in the previous case. Okay, so we have customers information which is stored here. Now this does not change very frequently. I mean, customer might change his email address or city, but those are not very frequent. There's no frequency to that. He might change his house city in 5 years, he might not change it, right? So these are called dimension table. Similarly, let's say product table. A website, or let's say you're having a store, you will have limited products only. For example, you might have 50 products, 60 products, or 100 products, right? You create a catalog of those products. Okay, you just store them. It does not change on an everyday basis or a very frequent basis. Okay, similarly, date and like these kind of table. So the difference between fact table and dimension table is that fact table is something that keeps on changing frequently. Dimension table is just a property which does not change very frequently. That is the difference between a fact table and a dimension table. Any doubt in this?
Any other points, bro?
No, these are the only two difference between fact and dimension table. No other difference. Table is table only. For example, let's go in the normalization example. Let's go into that. Okay, this was a table which I had. Now if you see, this is a fact table, because total amount that the customer is doing transaction is getting changed, right?
Yes, bro.
But what we have done after normalization, we have split it into 4 parts. Now see this part: product price. Does this table change very frequently? Yes or no?
No.
So what is this? This is a
Dimension.
dimension table. This information, customer details,
No.
does it change? So what is it?
Dimension only.
Dimension. This information, transaction ID, transaction amount,
Amount will change.
transaction data will keep on updating very frequently, right?
Yes. Yes.
There's a data in your company where all the transaction comes in, so it will keep on changing every second. So this is a fact table. Okay, this is also fact table because it is a transaction. So now you get the difference.
Transaction, product, quantity.
This is also transaction table only.
Why, bro? Quantity will be maybe increase or decrease.
Right? Transaction, multiple transaction will keep on happening now.
Okay.
These are only 6 transactions. A company can have hundreds or millions of transactions every day. You don't. This transaction, in this transaction, person bought 1 quantity or 2 quantity. You're looking at this. No, look at this. In a day, there can be hundreds of transactions, 200s of transactions. Number of suppose you have a transaction table. It will keep on changing every day, right?
Yes, bro.
This is that table. What didn't you understand? Tell me.
The transaction I did get, bro, frankly.
Okay. Suppose you have a transaction table in your company.
Yes.
Okay. Every time a customer purchases something, that information gets stored in that table.
Yes.
Now tell me this thing. Will that information be, will that table change continuously or not?
No, just the information will be updated.
What
Like
information will be updated?
like how many transactions has been done. That's
So let's say you have a table transaction ID and transaction amount. This table tells that suppose this is your company. Okay. Every time customers purchases something in your store. Let's say you own a Walmart store. Okay. Every time customer purchases something, a new transaction reflects in. Okay. You start your day at 7 a.m. Transaction 101 came in. Amount of, let's say, $100. Okay. Also add one more column. You were saying quantity. Customer purchased 1 item. Okay. Okay. Is this clear?
yes.
First part.
Yeah.
Now at 8 a.m. another transaction came in. 102. Amount $200. How many items the person purchased? 3. At 11 a.m. another transaction came in. 103. Amount, let's say $500. Quantity 2. This table will keep on updating regularly. Yes or no?
Yes.
So is it a fact or dimension?
Fact, bro. Fact.
That's what I was saying. Now relate to this. This transaction ID. What is happening? Transactions are coming during the day. First transaction, second, 6, 7, 8, 9, 10. So many
Updating.
times.
Yeah.
It will keep on updating regularly, right?
Yeah, bro.
That's why it is a fact table. Now do you get it?
Yes, bro. Yes.
Is there any You do not need to go through 4NF and all that. Is there any link between 1NF and dimension table? No, there is no link. I mean, you try to what you achieve at the end of anything. No, there's no link between I will say NF and this factor dimension. They're separate concepts, I will say. You can try to relate, but they are not. Okay. So do you guys understand the fact table and dimension table now?
Yes, bro.
Anyone? Anyone? Any doubt?
Bro, what is that 4NF, bro?
There was 3NF. Na? Someone said that, okay, next 4NF. That is also possible. That's what she said.
Okay.
Any doubt, anyone? Okay, just last 2 slides for today. So these were the tables we discussed. These many tables are there. Okay. Now there are 2 types of schema that you should be knowing. One is called a star schema. Okay. In a company, in any database, data is stored. So what is a star schema? That you will have a fact table, right? Now a fact table will have multiple dimension table, which we just saw. Correct?
Yes, bro.
Just like we created above, that before 1NF we had a table, and after 3NF we had 3 tables.
Multiple. Yes.
So one will be fact table. It will be connected with various dimension tables. So what does this look like? You have a center thing connected with different. So what does this figure look like? This looks like a star. That's why it is called a star schema. So a database, tables in any database are mostly in form of star schema. So this is the meaning of star schema, that you will have as, remember, there can be multiple fact tables. In this diagram you see only one, but there can be multiple fact tables. So there will be a central fact table. It can be one table or multiple tables connected directly to multiple dimension tables. Okay. And because this figure looks like a star, that's why it is called a star schema. Now dimension tables are denormalized. Okay. Because they contain mostly they contain all attributes without further splitting. Okay. Mostly. Yes. Fact table can have fact table. Yes. Okay. Any doubt in the star schema? So this is our star schema. For example, let us say this is a database which has some central data, then customer dimension, actor dimension, genre dimension, time of the day, the shows viewed, that person watched these shows. Yeah, in star schema there can be multiple fact tables. There can be multiple fact tables. Yes. Right now we are just seeing one. I'll show you diagram after this one. You'll see that. Okay. So this is that, because these form shape of a star. That's why they are called star schema. Okay. See this. This is your fact table, sales. Okay. This is your fact sales table. These are product dimension, product ID, product size, product color, product SKU. Right. Now this is a dimension table, because this cannot be split further. Now this is another dimension, this is another dimension, and all these tables are connected to a basically central table. Okay. Can schema have? Yes, that's what I said. You can have lot of fact tables. Each fact table can have multiple dimension tables. So that is possible. See, this is just a sale table, right? What if there was another table of in the database, let's say of stock, and the data table runs, and another table, for example, profit. These all become different fact tables only. Correct. So there can be multiple fact tables in a database. This is also a star schema. Okay. So now An advanced version of a star schema is basically called a snowflake schema. So the question that you guys were asking, okay, the snowflake schema is a more complex version of a star schema. Can any schema have only one fact table? Yes, it is possible. It is possible. It is very obvious that you have only one fact table and nothing else. That is also possible. You have one fact table and one dimension table. That is also, so one fact, one dimension table. That is also possible. You only have one dimension table. That is also possible. You do not need to store to have all fact table and dimension table. But when you have multiple tables, you classify them as either dimension or fact tables. Okay, then you try to form them, see what is the relationship between them. The relationship comes out to be like a star schema. That's what I mean. So a schema can have one fact table, or it can only have one dimensional table. That is possible. Okay, now come to snowflake schema. So what happened that in dimension table are normalized to reduce redundancy. So basically, as we spoke ahead in the previous, that what if your dimension table can be further split up? What if it is normalized? Okay, so this becomes your new fact table. So someone was asking, can there be multiple fact tables? Yes. So this was your main fact table 1. Now this dimension table is split into 2. So this becomes your fact table 2 of your database. All right. This becomes fact table 3 because it is further getting split. Okay. So when dimension tables can be split further, because they still have not reached the level of normalization required, then there comes the snowflake schema, that you have a central table connected to dimension. Now each dimension is also getting splitted into various things. Okay, another example, you see this. This is your central fact table. Okay, it is connected to dimension table. This is a dimension table. This is a dimension table. Dimension, dimension. Each dimension is further split into 2 tables, multiple tables, right? So if you see, this is called a snowflake schema, where a dimension tables can also be split up like this. So this is your how your database is structured. That is how the relationship in the database exists. Okay, this is a fact table and multiple tables. There can be multiple fact tables. There can be multiple dimension tables in your database.
Bro, but previous slide there is no fact table, like another fact table.
This becomes your new fact table, na?
Okay, okay, but it's called dimension table.
It just named as dimension.
Okay.
Discuss the property. What is a fact table?
Fact table.
You just forgot.
No, bro. Fact table must be like.
So just think like this. There can be multiple fact tables. What did I say? There can be multiple fact tables. Okay. These diagrams might not constrain all the scenarios, but understand that there can be multiple fact tables inside a database. There can be multiple dimension table inside a database. Okay.
Okay.
Now each dimension table can further be split, can further be denormalized or normalized. Okay, into further. So when you have only such one case that you only have one dimension table which cannot be split further, that is called a star schema. But when your dimension tables can also be split up, that there comes the snowflake schema.
Okay.
Okay, so this was the last slide for today.
But majorly, what we will use, bro, in
star schema.
Star schema.
How to convert snowflake to star schema? We'll come to that. Like once we get code, you have to eventually code it, right? All this happens. Whatever SQL queries you write, they are if you try to look from the top, the bird eye view is that you are converting snowflake to star or star to snowflake. Those type of things you do generally. Okay, so these all will be done through SQL queries that we are going to do. Okay, sorry, yeah, sorry, I forgot to cover entity relationship diagram. Yes, yes. Yeah, is this part clear to everyone? Snowflake schema.
Yes, bro.
Entity relationship diagram is nothing. It's just that how you know cardinality, right? One to many, many to one relationship. Okay. Now suppose you have to draw those relationships in a slide, in what particular diagram. They are called entity relationship diagram. So let me show you. Where is it? Oh shit, I lost it. Entity. There was a very good there's a very good article that I searched. I wanted to show that, but no problem.
You can go to history, bro. History.
I'll check that. So just a second, give me a second. There was a very good example. Not this one. Wait a second. Yeah, it's something like this. Okay. I mean, there was a better article. I'll check that and send you. But what happens that for example, two tables, right? They are connected either through one to one to many, or many to one, right? There are three types of relationships. So what you do eventually in ER diagrams is that suppose you created a table customer. Okay. Let's say created table customer. And let's say there is another table transactions. And let's say there is another table let's call this physical location. Okay. Now see this. There can be multi, just like we saw there were multiple tables in my schema, right? For example, I'm just taking an example of three tables right now. Now these two tables, remember we were talking about relationship. So this is, so this one table is called an entity. Okay. Entity relationship diagram. We're talking about that. So what is an entity? What is one table? What is the central meaning of your table? That is called entity. Now these two tables are connected. Now tell me this thing. Your customer and transaction, is it a one to many or many to many relationship? Or one to one?
Bro, one to many, bro.
One to
Customer.
many, right? One customer can do multiple transactions, right?
Yes.
And one transaction can only belong to one person. It cannot belong to multiple people. So when you have many, so you use this figure. This shows that and here you do not use anything. It means that one to many. Okay.
Okay.
And here, suppose these two tables, a customer and physical location. Is it a one to one, many to many, or one to whatever relation? Which relation is this?
One to one only, bro.
One to one. So this is connected like this. Here you do not provide these things. Okay. So that's how you create a diagram to understand how my tables are connected. Right now, when you have very complex set of, for example, we just saw this one, right? Now let's look at this. Okay. These two tables, this particular double says that it is, you cannot come in back direction, something like that it means. But see how tables are connected. Okay. So there will be a line and there will be arrows. The main thing is this arrow only. You want to see three types of relationship: one to one, many to many, and many to one. Okay, so there can be three possible scenarios. One was this. One for many to many, it will be this. Okay, for one to one, it will be this. So you just have to draw the whole database column, whatever you need, like this, and you will create a entity relationship diagram like this. Okay, see, uh, relationship card, let's read it. This says mandatory one. Okay, mandatory many. So this means that this is connected to only one. Okay, optional one. In optional, they have put a uh, like around something. Okay, around some optional many. So that's how things are varying. I mean, these are just notations which you should know. So if you try to see that, let me just rephrase the connectivity. So there are two tables, table A and table B. They can have many connections. Okay, so as you mentioned, if it is only mandatory, only one to one connection, you will use this one. Okay, as mentioned. If you are saying no, it is optional, then instead of this, what you are doing, you're saying optional one, something like this. Okay, and when there is many, you're using this. So these symbols are there. You can find it anywhere online. Like, you don't need to remember all that. You should just know that, okay, the diagram is given. If you have to look at the table, understand, someone asks you, tell me give me the schema of this particular thing. So that's all you should know. Okay, now this is called an entity relationship diagram. Mandatory and optional in real-time scenario. So a customer, for example, I will say optional will be when values are missing. Right? If there is table, for example, you do not find a one-to-one relationship. Let's say that ID is missing in that table. For example, there's an ID 101, and in the second table the ID is missing. That becomes optional there. Remember foreign key, I mentioned foreign keys are optional when there is null or those kind of values. So mapping happens based on foreign key, right? So foreign key can be null. So that's why they say optional. Optional mean it could be null, and mandatory means that no, it null should not be there. All the values should be there. Okay, is it clear now? Anyone, any doubt? So this was the today's session. I know it was more of theoretical, but this was all the theory that we had to cover. We covered in the first two classes. Next week onwards, it's everything is about SQL, query, questions, that only. But this all theoretical knowledge is very much required. I'm telling you, in interviews, they will test you. They will definitely ask you. Even I have been rejected. I remember this because I have been rejected once for calling fact table dimension and dimension table fact. This was like when I was like 6-7 years back, not right now, but that's why I remember this. So this is very important. It's asked very frequently. What is normalization of a data? They will not ask you, tell me what happens in 3NF. They will ask you, what is normalization? Can you give me an example? So there you need to tell an example that suppose we have a customer transaction table. The customer values like customer address, location, these are redundant things, right? So we do not want to copy them again and again. So we just store them in a separate table. That, right?
Yes.
So you just need to know this topic. Then comes cardinality, one to one, many to one, those. Then comes snowflake, whether your database is a snowflake schema or star schema, that you should know. Okay, because a lot of time when you create presentation, when you have to present to something, or even like schemas are required in a lot of places. Okay, you have to declare your schemas. So first of all, you need to create these diagrams, entity relationship diagrams, and everything. So SQL is, I will say, is just a tool which you use, but eventually what you do are these things only. Okay, so this theory was very important. That's why I covered in the first go. Okay. Some reference question to prepare for interview. I'll share a list of questions on this theory that are asked in interviews. Okay, so just prepare them, then you'll be good to go. And if you have any doubt, then we can discuss those questions in a doubt session.
Bro, can you share any questions, bro? Like, first, initially we have solved, right?
Sorry?
Initially we have solved, right, questions. Like those questions, any questions will you share?
I said I'll share a list of questions. You can have them, you can read them. If you don't understand, we can have them in doubt session.
Okay, okay.
Coding questions I'm not sharing this week. I will give you next week only. Okay.
Okay.
This was just the first week. So like, but I have taught you basic coding. A lot of you were not able to solve the question number 5, which I expected. So make sure you revise
Yes,
those 5 questions.
yes,
Okay.
we will revise.
So that's it for today. I mean, we stretched a little bit, but I just wanted to finish this in today's class only. So I hope you guys understood. I know a lot of things that might be new for few people, but just try to digest it. This is just the theory part. I've shared the PPT. You can go through the PPT. Just know the terms. What are they? That's it. Okay. And I will share a PDF of interview questions, the theoretical interview questions that are asked around these. Just prepare them and do tell me about the primary key, whether a table can have multiple primary keys or not in next class. Okay. For this week, I'm not giving any activity, but this is the only week when I'm not giving any activity. Okay. Next week onwards, you will, because because I want to tell you how to solve SQL problems first before giving questions. Okay. That's why I'm not giving questions. So in next week, we will discuss how to solve any SQL question. Then I will give you problems. So this week you can relax. Okay.
So next class will be on Saturday
Saturday
morning,
10 next Saturday 10 a.m.
10 a.m. Okay.
Okay. So thanks a lot, everyone. Like if you guys have any doubt, you can text me. I'll answer tomorrow now because I have to go somewhere. But I hope you guys understood. This was. Let me know how you have attended 2 classes. If you have any feedback, if I'm going slow, not explaining something properly, whatever, do let me know either on group or DM, whatever, right? So that I improve before next class. Okay. Do let me know the feedback, and we will start the coding from next week. Uh, Revise things, and whatever we did now, in the somewhere in the mid of the week, you can be given a surprise test. I'm just telling. Okay. So prepare yourself. Okay. Yeah, I know that, but because a lot of people are there, either their Saturday mornings were not free or Sunday, so I had to. So what I have done, that on Saturday I've done morning, on Sundays I have done evening. That's what I have done, because
So
otherwise I was not able to manage people.
can't we manage for both evenings only, bro? Like Saturdays and Sundays.
There are a lot of people who will be left now. That's the problem.
Morning,
A lot of people who were not available in mornings, in Saturday evening, in Saturday evenings.
morning,
Lot of
morning
lot
also they won't, bro.
Yeah, so are you telling me what is the solution? Thing is that few people are available, few people are not. If I keep in morning, then also I lose few people. If I keep in evening, then also I lose people, right? So how should I go about it? Like, you guys tell me, like, what is an ideal solution? So that's why I did a morning one class and evening other class. That's what I did.
Bro, recordings will be there, right, bro?
Yes,
Few
recording.
are who are not attending, they can check those things.
Yeah, I can. Yeah, I mean, we can switch it if you want. Like Sunday morning, we can do Saturday eve. But problem is that, think this way: if I do Saturday evening, okay, uh, remember classes go up to like generally 12 p.m., 11:30 p.m. Then again, will you be able to take a 3 to 4 hour class once again within a span of like just after you like sleeping and waking up?
No, bro, I'm asking like to Saturday evenings only. Saturday evening and Sunday evening, both. Like
I are
how
not
this.
possible. That's what I'm saying, because there are a lot of people who were not able to join because of this.
Okay, bro. Okay.
Okay, I took a poll. That's why when I took a poll, maximum people voted for Saturday morning and Sunday evening. That's why I decided this way. But
Okay.
that's the best I could do. Remember the doubt sessions we will be having from the week after that. That will happen on weekdays. You can guys can let me know. Mostly I will keep on Thursday evenings. Okay, but I mean, I'm sorry, I tried my best, but I cannot accommodate everyone. That's the problem. So I came up with this solution. I can do reverse. I have no problem if you guys say that do Saturday evening, Sunday morning, but then it will become very hectic for you guys. That first 4 hours, like 3 hours session, then again sleep, then again wake up, then again three. You will not get time to revise the things. That's the problem.
Okay.
But still you can write in group, like we have the week to decide. If we find any better solution, we will take that. Okay.
Sure.
Okay, so thanks again everyone for joining. Do let me know if you're not able to understand anything. If there's any feedback, do let me know, please. It's very important before I prepare for next class. Okay.
Sure. Thank you.
Thank you everyone.